Hi, everyone, and welcome at another episode of the October sessions. We're at episode 3 of our 4 episodes that we'll have. We'll be talking about natural language processing. Interesting industry, lots of things going on. But of course, I'm not here alone as a host. We also have Amy. Hey, Amy.
Hi. Hiya, how are you doing?
I'm fine. I'm very glad to have you as a co-host today. We already had quite some nice sessions in our previous October sessions. Well, you remember our first one?
Yep, so I
Getting
was going to
started.
say, for anyone that has seen our previous shows and was in the chat, I was Amy, the moderator at the time, that kept messaging you all the time. So it's nice to see you all. This is what I actually look like, rather than just typing.
It's not just the name. There's a person behind it. It's not just AI.
There's a whole thing going on here. I know. Amy, the AI actually got a bit of a swing to it, hasn't it? But yeah, we are. What are we now? Episode 3. Goodness me,
Yeah.
we're 3 weeks into October out of 4 episodes.
Almost reaching the end of the year again.
I know, right? How fast is it all going as well? I can't believe it. We were just talking about. So I'm in the UK, and it's getting so dark outside now. Here, it gets dark in the winter quite early, and yeah, like we were doing some testing, and the sun was coming in. I was like, don't worry, we won't have that problem.
We are based here, the studio. We are in Holland, but we have guests. We have Amy as a guest, but I have another surprise guest. Look who we have here. Bits is also joining us.
We have a bit. I have a.
Yeah.
His cousin is over here. He's a little far away.
He wants to learn more about NLP, so I'm sure he will enjoy the session just as everyone else. So we had our session already more basics about getting started with AI, which was very interesting. And we saw some new features in the Azure services like the metrics advisor, which is really cool. We had our custom vision last week, where I really enjoyed the session where how you could even build AI models with JavaScript. I didn't even know that was possible. Like,
I'm not a huge fan of JavaScript myself. I am going to have to throw it out there. However, it is very impressive that our amazing speaker was able to kind of show us how that was able to be done as well. You know, we always maybe think of maybe two specific languages for data science, and so it was interesting to see that.
Yeah. Also, the session we had from Richard Campbell was really amazing. He's really a good speaker, and he really went from actually what is AI, and then where are we now? So that was really cool.
Yeah, the history of AI is such a good story. If you are joining us and you're just getting into AI, I highly recommend going and doing a little bit of research about where we've come from and how we've got to where we are right now, because it's so interesting to see a lot of the research that has really broke these glass ceilings of things that we can do is actually something that might have been quite old, or actually in some cases was kind of said no, that's not the right route to go. There are these other routes knowledge bases and more structured types of machine learning. So it is fascinating. So yeah, if you're getting into it, I can only recommend going and taking a look at the history. I think we can learn a lot.
Yeah. So today we're going to talk about NLP, natural language processing. We have an amazing lineup again of great speakers. We have Josh Simmons from VMware. We have Elron Bandel he's a researcher at the Bar Ilan University. We have Vered Schwartz, who works at the Allen Institute for AI. And we have Ines Matoni, who's a founder at Explosion and actually helped building Spacey, founder of Spacey library, which is a well-used NLP library. Yeah. But before we go on, there's some small things that we, of course, want to share with everyone. If you have any questions during the sessions, please don't hesitate to use the chat on the platform that you're using to just send us the question. We will receive them and we will ask the speakers, the questions that you have. We will moderate them. There's a chance to win also a $50 Amazon card, which is given away by C# Corner. So thank you very much, C# Corner, for doing this. If you want to win one of those Amazon vouchers, you need to go to globalai.live/win-action. So I'll repeat it again, globalai.live/win-action. So also send out tweets, because we will also moderate through the tweets who has most creative tweets that is sent today.
We've had some good ones in the past, right?
Yeah, it's quite some funny ones. Who really took up creativity as creativity.
Yeah, and make sure you put hashtag global AI community so that we know what we're looking for. We're always trailing through them in the background and taking a look at all your answers on the platform. So do converse with us. We don't want this to be a one-way show. We want to hear from you.
Yeah. So what do you think, Amy? Will we go to our first speaker?
Yeah, definitely. Definitely. Let's bring on our first speaker and get this
let's
show
welcome
on the road.
Josh. Hi, Josh.
Hey there.
How are you doing?
Both. Yeah, I'm doing well. How are you both?
I'm fine. How are you, Amy?
Yeah, we're good. It's getting a little late, so it's 6 p.m. here. I do actually have coffee. This is against the rules normally at this kind of time of the day, but we have 3 hours of jam-packed agenda. Oh, Sammy, I'm disappointed if anything. But Josh, thank you so much for joining us. It's an absolute pleasure to have you. Can you tell us a little bit more about yourself? Tell our watchers what's happening.
No, sure. Yeah. So thanks for the opportunity. Let's see. I've been at VMware about 10 years. I have 2 roles at VMware. I'm the chief technologist for high performance computing. I work in our office of the CTO in the advanced technology group. And in that role, I spend a lot of time looking at both high performance computing and also machine learning workloads in understanding how to get the best performance out of those workloads, because clearly, the data scientists need stuff underneath them to run on, right? And we spend a lot of time looking at how to make all of those models, et cetera, and the training and both training and inference run as well as possible. But I also run, which is maybe more relevant to this discussion, I run something called the VMware Machine Learning Program Office, which is a small central team that really works to coordinate our machine learning activities across the company. And we get involved in things like community building. We run internal competitions to help our employee population upskill themselves. In fact, this week we're running an internal VMware machine learning conference for our employees over the entire week, actually.
Nice. When we were talking about before, we were really wondering, like VMware, we never would link them to natural language processing. And when people say VMware, well, we always think about virtual machines. I'm sure there's way more than that behind the screens. So we're really looking forward to your keynote about this and what VMware and your department is exactly doing with NLP. Yeah. So I think with this, we would like to give you the word and show us what you're all doing there.
Okay, great. Yeah, let me just share slides here. Let me know when you can see them. Yeah, they're visible. Perfect. Okay, so I thought for a while about what the title of this talk should be. This is a really boring title. Unfortunately, all the good titles involved using the word bug and some kind of a pun. And I didn't think that was going to translate into a global audience, so I didn't try. But my intent here, going back to something that Amy said maybe a little bit earlier, is I'm going to fly at a relatively high level here. So for people that aren't into the details of NLP, I think this will still be very accessible. It's really meant to give you just an overview of a couple of examples of the types of things that we do inside of VMware around NLP. Okay, let's see if I can get this to go forward. Okay, so just really, I want to give you enough about VMware just so you understand, to set context for the rest of the presentation. This isn't about VMware as a business really, but really what we focus on. For those not familiar, we are, I think at last count, something like the 5th largest software company in the world, and we have roughly 500,000 customers worldwide. And we're in the business of delivering what we call the digital foundation that these businesses run their workloads on top of. So you can think of their data centers running VMware software, and then that software is being used to host all sorts of workloads and applications, including machine learning applications. So really the most important thing to get from this slide and from what I'm saying is that we are a software company and we write prodigious amounts of software. We have millions and millions of lines of code of software in order to enable all of the stuff that we do. Now, if you look at what we do as a company and kind of the intersections between what we do and machine learning, it actually intersects with our type of company in 3 different ways. And we call them, as you can see here, we call them smarter businesses, smarter products and services, and smarter VMware. And smarter businesses is really about making sure that when customers want to run their ML workloads or their AI workloads in the data center on top of our software, on top of our virtualization software, as was mentioned earlier, that it runs really well and they have full access to all the capabilities that VMware brings to bear when we're delivering this sort of digital infrastructure. So that's one of the 3 pillars that we focus on. And that gets into a lot of things around application performance, et cetera. The second place that we spend a lot of time on is what we call smarter products and services. And that is having expertise internally, having data scientists and engineers who work together to add machine learning capabilities into our products and services to make them smarter, make them scale better, make them more autonomous, et cetera. That's a pretty big effort as well. And then the third one, and this I think would resonate with most organizations, is that we do ML internally for our own benefit, right? So we do it to improve efficiency or productivity. And the examples that I'm going to give you today really kind of come out of that category, like some of the things that we're doing internally to make things better. And in particular, we're going to be talking about the area of bugs and software bugs and bug management. So, very broadly, right, NLP, we know, encompasses a pretty wide array of different areas, within it. Things like question answering and speech recognition and language translation, et cetera. In particular, when we look at, and this gets to answering the question of what kind of NLP are we doing internally, so we have lots of documents, lots of unstructured text, things like SR tickets, which are support request tickets. So that would be a customer writing in and saying that they've had a problem or some kind of a bug and they need help with it. We have internal tickets that are raised. We have product documentation, knowledge base articles. Our products generate lots of log files, and those log files, you wouldn't look at those as being English or natural language per se, but they're still amenable to applying NLP techniques to them. And so we can look at that. And even looking at source code. And we haven't done a lot of that to date, but as I said, we have, literally millions and millions of lines of code. There are some really interesting things that we've, seen in the literature and that we started to think about in terms of places we might apply NLP. But if you sort of think about how you might apply NLP to these sorts of things, these sorts of document sources, these are the sorts of things that we get involved in. Things like assessing customer sentiment analysis, right? So being able to look at, for example, conversations that are going on in customer forums and trying to understand whether or not customers are trending happy or trending unhappy with respect to some of the things that may be going on with respect to, say, product releases. I mentioned code analysis and chatbots as another area. What we're going to focus on in this short talk is really around bugs, and in particular, bug classification and bug deduplication. Okay, but before I get there, this will be an obvious statement maybe for the NLP folks, but I think it's an important thing to talk about at least a little bit. So this idea of, what is, we're talking about NLP, right? So natural language. Well, sometimes the language is not so natural. And what I'm showing you here are some examples of some very reasonable sentences that people at VMware might write or our customers might write. So for example, VMC uses NSXT to create and manage internal SDDC networks. That is completely intelligible to me. I'm sure that doesn't mean much to many of the people that are listening to this discussion. So the point here is that at least in our industry, and I expect in many other industries as well, there's a fair amount of jargon. For us, it's pretty much everything begins with a V at VMware. So we have lots of acronyms and product names and just jargon generally. And so it's really important that when we build NLP systems, they're actually able to understand the language that we and our customers use. And the reason I mention that is because there is obviously a lot of work going on in the community. And Google, for example, is a big contributor using things like BERT to build language models that people can take as a starting point for doing their own NLP. Well, those starting points are based, generally speaking, on relatively, standard, let's say, English sentences without a lot of specialized vocabulary in them necessarily. And so, we have to take special action to deal with that. And it goes beyond just the jargon. There are also issues around usage, right? So if you look at the word switch, right? So the sentence, the switch on my iPhone is not working. That's a different use of the word switch than VMware vSphere distributed switch provides a centralized interface. Or how can I switch a raw data mapping between physical and virtual compatibility modes, right? So it's the same word, but obviously in English, it has different meanings. And it can even be a different part of speech, right? It could be a verb versus a noun. So the context really matters. And so why am I talking about all this? Well, you need to understand the language that you need to understand your input language, and then you need to have a way to map that input language into some kind of numerical representation that is more amenable to actually applying NLP and just ML techniques to it generally, right? So this idea of word embedding is a key concept in NLP, as I'm sure many people are aware. So initially at VMware, we started off, as I think many people did, with what were sort of state-of-the-art approaches at the time, things like Glove and Word2Vec, in order to build a set of VMware word vectors. And that actually was done within my team to build a standardized set that we could then share with other teams inside of VMware so that they didn't have to go to the trouble of building their own sets of word embeddings to do their own NLP. Now, since that time, we've moved on, and I guess you could say we've become more sophisticated, and I'll talk about why I'm being a little hesitant about using that word in a minute, to something like a BERT model, a language model, where what we're doing, and it's sort of shown schematically on the bottom there, is that we're taking the sort of pre-trained BERT models that Google makes available, so that have been built with relatively generic vocabularies, and then essentially doing transfer learning on top of those by bringing our own corpora, like the VMware documentation set, knowledge base articles, and even Reddit discussions that are about what's going on at VMware and VMware products, by applying that to the pre-trained BERT model and then building what we call VBERT. So we now have a VMware specific language model from which we can extract embeddings that we can then use for our own NLP. And I guess I do want to make a comment here that, and maybe this goes back to the sophistication comment I was making a second ago, is that very clearly it's been shown that you can do some very amazing things with BERT. The fact that it captures context, and if you think about the previous slide where I showed the word switch, well, with a word vector-based approach, you would have a single embedding representation for that word switch, regardless of the context within which it was used and its underlying meaning. Whereas in BERT, it has the sophistication to be able to create different word embeddings to represent that word in different contexts, right? So it clearly adds value, but it does come at a cost, right? So these large language models are extremely compute intensive, requiring very large amounts of hardware acceleration, for example, to run them in any reasonable period of time. From an eco perspective, they're pretty unfriendly, right? They consume, the carbon footprints are quite large, despite, of course you are getting something for it, but from our perspective, when we think about sustainability, we're not so happy about the eco footprint of these really heavyweight approaches, despite the fact that they deliver value. And so, in fact, as I mentioned, we're running a conference this week within VMware, and we had a talk by a team that actually is still using word vectors. So they're using a much simpler approach and delivering excellent results, really high accuracies on what they're trying to achieve. And so one of the lessons I would share here is that it's not always necessary to jump forward to the latest and greatest. And in particular, I think it's worth looking at some of the more basic and maybe even some of the more classic ML approaches when trying to understand how to solve not just an NLP problem, but an ML problem generally. Don't necessarily jump to the latest and greatest is really what I'm saying. So, okay, so Bugzilla, now we'll start diving down a little bit into bugs, right? So Bugzilla is the product that we use internally for everything to do with tracking bugs that engineers and others find in our products. And really what this slide is really meant to demonstrate, if you look at the usage statistics on the left-hand side there, you can see that this is a very heavily used piece of software. We have, like any software company we have a fair number of bugs that need to be tracked down and fixed, based on either exploration that we've done internally or on customer reports. And what I want to do, again, really briefly, is touch a little bit on two particular areas that we've spent some time on applying NLP techniques, bug duplication and bug routing. Okay, so let's talk about bug duplication. So the basic first observation is that it's actually relatively common that you could end up with the same bug being represented more than once in the bug database. And that's problematic, right? As we get, and the reason that happens is that, partly at least, that because we're releasing products so quickly and the pace is so quick, it's sometimes just by its nature, we end up with these duplicates. It also can be the case that we have newer engineers who are in the company who may not be aware that there's already a bug filed. And the problem with the fact that you have these duplicated bugs is that as I said, you end up with the duplications, and they can even be multiple duplicates coming in a single day. And so the problem with that is that it leads to duplication of effort to produce bug fixes, right? So if I'm working on bug A and there's another bug that's essentially the same bug, and it's been filed as bug B, and another engineer is independently working on that, that is a wasted opportunity. What we really want to be able to do is notice that A and B actually really are very closely related, and then merge them together so that we have full information about what that bug is actually about, and we can deal with it more quickly. So it's really about reducing the time to fix the problem and increasing the customer experience, in the customer base. So those are the reasons for looking at it, and NLP can actually really help solve this problem. And so just to give you an example, so this is not an example of a VMware bug. This is a bug from the Mozilla Firefox public database, right? So here's bug 134649, and here's another bug. And if you look at this, and we've gone through and highlighted some of the phrases here, these are not written, they're not identical, they're certainly not identical, but in fact, they actually are reporting the same problem. And so what we would really like to do is to be able to notice that these are the same problem and to be able to merge those bugs together. So again, at a high level, the first part of this is using those embeddings and reducing these bugs into a numeric form that actually can be used for doing text similarity. And the text similarity metrics that we're using are not complex. I believe cosine similarity is probably the main one that we're using at this point in order to determine whether or not a particular bug that has just been filed is actually a duplicate of a bug that we've already seen. All right, so you need to do some kind of a document similarity between them in order to do that. And we look at the text description that the engineer has entered, and we also look at some of the metadata as well. And then we do this text similarity comparison between that bug and existing bugs. Now, a problem with that is that, let's say we have several million bugs in the database. We're a 20-plus-year-old company. Over the lifetime of the company, there have been a lot of bugs. So how are we actually going to do that in some kind of a reasonable way? So it turns out that by doing analysis, what we're able to sort of empirically determine is that 95% of those duplicates that are entered occur within about 56 days of when the other bug was actually filed. And so we can actually take that number, maybe move out a couple of standard deviations, and give ourselves a time window within which we should look for bug duplicates, rather than looking back, say, 20 years, which isn't a useful use of time. And this is important because, especially if you're trying to do this in any kind of an interactive fashion, looking through a million bugs is just not going to work, right? So this windowing, this temporal windowing, is one approach that we take. And then the other thing that we do is we've also noticed through analysis that it tends to be, so we have a lot of products, and it tends to be that these duplicates appear either in the same product or within maybe a small family of products. So this is another way we can actually reduce the search space in order to make this a tenable solution. And so from a kind of high-level perspective, how does this actually work, right? So we have the bug database, and in the bug database, we essentially have a labeled training set, because anytime an engineer determines that a bug is a duplicate of another existing bug, they mark it as such, right? So we will know which ones historically are actually duplicated bugs, and we know what the duplicates are, or multiple duplicates in some cases. So we have that, and we can use that to build a training set of both duplicated and non-duplicated bug pairs. So once we've done that, we take the bugs, we create the word embedding using transformer in this particular case to do this, the document scoring. We extract the features, so the time distribution that I mentioned, and then we're using two different approaches. We're sort of benchmarking them against each other. We used a deep learning-based approach, and we also used XGBoost in order to try different techniques. And then you basically, once you built the model, you now apply the model on a new bug report, and then generate reports for the duplicates that you find. And then, of course, evaluate the model performance based on users' feedback, and then feed that back, refresh the data set, and use that to retrain the model is really the idea. So when we've done that, here are the results that we have. So VBERT plus deep neural network is, as it sounds, it's using the embeddings from the BERT-based transfer learning that we did, and then VBERT versus XGBoost. And a comment I would make, it goes back to what I said earlier, about using sort of the latest and greatest. So XGBoost is doing pretty well, actually, compared to the deep neural network-based approach. Very, very close in terms of performance, just a little bit lower. Now, the deep neural network takes around 8 hours to train with an NVIDIA V100 GPU, whereas the XGBoost took only around 2 hours on the same GPU. So here's a case where we could potentially decide to take a slight hit in, say, accuracy in order to embrace a model that is not quite as resource intensive as the BERT model or the deep neural networking model. Okay, the other case I wanted to briefly touch on is bug routing. And so the idea here is that every time an engineer submits a bug into the bug database, we require that they categorize that bug, that they classify it into a particular product. And then within each product at VMware, there are several categories that they could file that bug under. Sort of think of those as subsystems within the product. And then within that subsystem, there are components that could also be specified to get even closer to the correct engineering team that should be working on that problem. And just to give you a sense, I think there's something like 6,500 unique components within the database across all the products that we have. So the idea is we would love to be able to help our engineers in some way do a better job of correctly classifying and categorizing their bugs. Because if you put them into the wrong category, as you can see here, right? So there are thousands of product category component combinations. Something like 20 to 28% of those bugs are misclassified at least once. And again, we can tell that by looking at the bug database. And when an engineer finds that a bug is in the wrong product or category or component, they reclassify it. So we have full visibility into that for building a labeled training set. Now, the cost of this is a bug that's misclassified could potentially take up to 1.6x longer to actually close, which is a problem, right? Because that prolongs the resolution time by anywhere from 2 to 20 days, which means that we're taking longer than we need to in order to get fixes out to our customers, which is always an issue in terms of keeping customers happy. So for us, this is kind of high stakes. Can we actually figure out a way to do this? And so we actually have solved this problem 3 times. The first time that we did, actually the first 2 times that we did it, we really focused on, actually going back for a second, we focused on assigning to the category level and weren't able to actually assign all the way to the component level. So we had an intern come in 2 summers ago, and we ended up adopting an approach, and you can see the reference at the bottom here. This is an approach that is very similar to the approach that Uber uses for their own bug system, where we have sort of a sequential dependency and a hierarchical classification happening here, where we're using a set of neural networks to first classify by product, then classify by category, then classify by component. And here we're not using the VBERT language model and those embeddings. We're using the much simpler word2vec and glove word vectors here. And so, key takeaway from this one, from a business perspective, is that we have deployed this. It's still early days in terms of the deployment. In terms of prediction accuracy, it's a little hard to explain exactly what the value is, but let me give you just a quick sense here. So, at a product level, it's able to get a 95% accuracy in terms of telling the engine. Let's imagine you're an engineer, a new engineer to VMware. You're filing a bug, and you really have no clue where to put this in terms of product, category, or component. So with about a 95% accuracy, we can tell that engineer which product it needs to be assigned under. And then we can get about a 57% accuracy, taking that to the category level. Now, you'll notice that the component level, at least currently, is quite low, just around 20%, although that 20% is still probably better than what the engineer is actually going to be able to do. Unless they have, reasonable knowledge about the products. And so even if we get them just to the category level, then it's much better than just being stuck at the product level and not being able to correctly predict a category level. And I should say that in the cases where they are a skilled engineer, and for example, they know what the product is, or they know what the category level is, we can do much higher levels of accuracy in terms of giving them recommendations about what the appropriate component or category should be. So the benefit of this approach from our perspective internally is that, yes, we're starting to solve this, this bug classification problem, but we're also building these sort of reusable models that which demonstrate sort of a hierarchical multi-class text classification that could be potentially repurposed inside of VMware for other activities. Now, the last thing I just wanted to quickly mention is that if you think about the sort of overall steps of conceiving your ML or NLP project, and you look at the steps here, it all ends with deploying and monitoring, right? And I think as the data scientists tend to focus a lot on the actual training and the models and the techniques, et cetera. And of course, that makes total sense. Of course, it's also true that a significant amount of time is spent at the front of this in data collection, labeling, and pre-processing. But we often get the impression that people don't spend enough time thinking about the deploying and the monitoring aspects. There's actually a lot of complexity here in terms of integrating these models into existing workflows in order to make them functional and put them in place in a way where the models can be monitored, where they can be updated, ideally automatically, so that you don't experience model drift, et cetera. And then just from an inference perspective, there's some things to think about, right? So again, going back to this theme about what's the cost of the model that you're actually using, right? Are you using a big neural network, or have you found some kind of a simple model, right? Well, that's going to have an impact on your ability to do really fast inferencing if you need really fast inferencing, right? So these really complex models, it's quite difficult to get fast inferencing. So you have to keep that in mind. You also need to keep in mind it comes down to sort of both a cost and a performance trade-off. Are you going to be using CPUs or GPUs or even say FPGAs for doing that inference, and what's that deployment environment going to look like in order to accomplish that? And then you're not done once you've created that model, right? Especially if you're very interested in getting high performance. So there are certainly inference optimizations that can be applied, things like quantization, binarization, pruning, et cetera, which all need to be looked at in terms of a potential accuracy trade-off, right? So maybe you take a slight hit in accuracy, but you're able to drive up, drive down the complexity, the runtime complexity of the model, and then drive up your ability to do faster inferencing. So this is just another area where I think from an NLP perspective, it's important to think about, I guess the lesson is it's important to think about the entire pipeline, right? Not just the sort of fun data science stuff in the middle, but all the hard work at the beginning dealing with data and all the difficult work at the end dealing with deploying and monitoring. And with that, I'm going to stop.
Cool. That was really interesting, Josh. It's something I never thought about using NLP for mbugs. But once you're thinking about it, maybe it could also be used like for customer feedback. Which feedback comes all together? Where are people happy about? Where are people not happy about, and so on? Absolutely. Very interesting. Cool. Yeah. You were talking also about deployments. Do you guys have specific processes in place to do your full deployment? Or
yeah, that's a great question. We do not, and this is something that we are actively discussing, because as your question implies, it's a really, really good idea to have a standardized deployment mechanism, right? So regardless of what tools you're using to actually create the models, why not have a standardized deployment mechanism? And we're working towards it, but I think we still have a little bit of distance to go. This particular project around the bug classification really was intended to be an end-to-end process, taking things all the way through to production and use it as a learning experience so that we can understand what the difficulties are in actually, doing that deployment in a good way. And in fact, just before getting on the call here today, I was talking with one of the lead engineers on the project, and we were talking about this idea of, have we really closed the loop in the deployment environment to the extent that, if you think about that bug problem, VMware adds new products all the time, and we add capabilities to those products all the time as well. So that list of products and that list of categories and components changes over time. So there really needs to be a mechanism in place so that we can automatically rebuild and retrain those models and redeploy them, ideally automatically. That's not a loop that we have automated at this point. It still requires a human in the loop to actually go rebuild that model. And that clearly is something that, needs to be worked on.
That's very, very cool. And also, a lot of people are commenting in our chat that they can just see this being so useful in all of the companies they work for and all of their GitHub projects. So being able to actually merge different issues. Actually, I'm going to dive in, if possible, with a quick question from myself. How selfish. One of the things that first came to mind when you were saying, oh yeah, like what we do is we look for similarity. So I was like, perfect. And then you merge them. Does the amount that you merge have some kind of weight in, say, like the importance of the bug? So I'm thinking you release new software and everyone has this issue, and it's obviously like really high priority because it's on like the home screen or something like that. Is there anything like that in your model, or are you mainly just using it to say, oh, we know we have this problem and here's all the detail?
Yeah, so if I understand that question, Amy, yeah, we're focused on finding the duplicates. There's no concept in this particular project around sort of the, fixing the, oiling the squeaky wheel in a sense, right? Knowing which bugs are the ones to fix first. It's funny that you mentioned that, because we had a talk this week by our CTO, Greg Lavender, and one of the things he brought up was actually that very point. He said that you can go into the bug database and you can look at the bug database and you will see that priorities have been assigned to those bugs. But that's different than, for example, let's say we mine an external forum and we see that lots of people are complaining about a bug that's labeled at like severity 3 in the bug database. Well, geez, maybe we should go fix that severity 3 bug, even though it's not as high priority as a bunch of other bugs, but it would deliver much better satisfaction to end users. And that's an awesome idea, and you're implying the same thing, and it's something we should definitely look at.
Oh, well, the global AI community, we're all here as idea generators, so all of our people online, submit your ideas as well.
Yeah, great idea.
I think another question we got from the public, which is quite interesting also, is like, do you assume that your existing bug knowledge base is always correct, or have you used your model to merge duplications in your existing knowledge base, or you only use it on your new bugs?
Yeah, so we do assume that the ground truth is in the bug database. That's true. That if an engineer, I mean, it's essentially equivalent to hand labeling, right? Somebody has gone in and said, this bug and this bug, yeah, definitely duplicates. And so we're relying on the expertise of our engineers to make that determination, and we proceed on that assumption. Okay. Sorry, I think there was a second part to that question that I might have missed.
No, well, I think you've answered everything. It was okay. About the new ones or based on what you already had. But with that in mind, you're grouping all your bugs together. So are you saying one specific bug is the parent of all of them? Or are you saying which one is more important than the other?
Yeah, wow, that's a great question. So I don't think I mentioned that this project, we also had an intern in this past summer, a PhD student working on this with us. And it's not an exaggeration to say, I think the internship was 12 weeks long. He spent at least 6 weeks working on questions just like the one that you raised, right? Trying to understand what the right way is to actually represent the data that actually exists in the bug database. So you're right. I mean, in a sense, the parent bug is the one that was filed earliest. So we start with that, and then bugs that were filed later, are sort of attached to it in our world, is I guess the way to think of it. And there's another interesting thing here. It's easy looking at the database and the ground truth to understand which are the duplicates, right? Because the engineers have said these two are duplicates. But if you're building a training set, it's really interesting to think about. Remember, we have to pick bug pairs that are both duplicates, that's easy. But duplicates that are bug pairs that are not duplicates, right? And that's really interesting how you make those selections, right? Because let's say all the pairs that I select, I pick a bug from product A and a bug from product B. So they're very, very different. And I give it to the model and I say, these bugs are not duplicates. Well, okay, it is kind of obvious that they're not duplicates. What I really should do when I'm picking bug pairs that are not duplicates is pick bugs that are in the same product and maybe in the same component so that they're in the same area and yet they're still different, because you want the model to be able to differentiate, find differences between those bugs, if that makes sense. Because if you don't do that, you're not going to be able to find bugs that are, subtly different.
Yeah. Oh no, it's very thank you so much for telling us all about this. As Sammy said, right, one of the most interesting things is just hearing about these projects that do happen in all these different companies. So one person I would like to bring on is actually our second speaker, who is Elron Bandel, and he has an incredible business chatbot that he has been working on for quite a while, and is going to be giving us an amazing session on. So hi Elron, thank you for joining us.
Hi everyone, thank you for having me.
Elron.
So we thought we would, we tend to do this in our previous sessions. We bring multiple people on the panel to get kind of these different perspectives on the same idea. And so, yeah, Elron, can you just very briefly introduce yourself and tell us a little bit about VerSpot?
Okay, so I'm a researcher at Ireland University, and during my bachelor degree, I very enjoyed my studies, but some of the courses were quite boring, and I started to think, like, how do you do actually the real thing that uses computer science, for example, chatbot. So I started to dive into this, and I started to find it extremely interesting, and then I started to create VerSpot, which is a new kind of platform for making chatbots for small businesses, only by using textual description of the business.
Very cool. And yeah, I've had a really good nosy around your website, and it is actually, and much like the videos on YouTube, and it does look like a super simple process to set up. And so I thought there was some kind of consistency here between Josh, what you've been speaking about, and how you've all been using it internally as part of your bug process to be more efficient. And Elron, it felt like when you're building these business chatbots for others, so I'm a customer A and I can go on, I don't need to know anything about machine learning, and actually I can go ahead and create a chatbot. We thought it could be quite an interesting perspective. And so I guess one of the first questions I kind of wanted to ask you both was a little bit more around what are some of the challenges around infrastructure as well as architectural design when it comes to implementing these things. So you're both doing things at extreme scale. Is there certain challenges you've seen? So I'm going to pick one of you, or Josh, I'm going to put you in the hot seat. Is there specific challenges you've seen when experimenting and deploying these different bots?
Yeah, it's a good question. So I mentioned that we were using BERT for the language models. That does require a certain amount of computing horsepower. But luckily, we do have a reasonably significant number of GPUs available internally within the company, so that's not too much of a problem. But I didn't mention that we have probably something like 100 ML projects running internally within VMware, and so in aggregate, it turns out that getting access to resources can be somewhat challenging. Of course, I happen to be a little bit lucky because I run that central team, and we have our own private resources that we can go and use. So
that's cheating, yeah.
A little bit. But yeah, you're right. I mean, getting access to those resources can be somewhat challenging for sure.
How is that for you, Elron?
What exactly? Sorry.
How is that for you? How do you have issues with infrastructure for your project?
So for me, I find the most challenging part is that basically, if you want to use cutting edge technologies, things are coming out every day. Every day you read cool papers which you would like to try on your system. And if you basically have all your code like together in one piece, it's very hard to try and change things, especially if you want to try some of them in production with real people that are actually using your models. And I find it very useful in terms of architecture and infrastructure to separate every model from the rest and actually deploy it on completely different server. And as much as possible to separate it actually from the specific machine it's running on, and to use some virtual machine that can actually make it possible. Thank you. They can make it possible for you to emigrate from one cloud service to another, or to try and use different models that use specific features of specific machine you really want to try. And it's extremely useful to separate the models and make sure you can run them and try different ones very quickly.
I mean, I have to jump in and say, yeah, of course. I think it's awesome you're running in VMs. That's something that we see internally and also our customers see, right? This what you're implying is this ability to encapsulate the entire software environment in that VM and be able to do that for different environments simultaneously, and then be able to schedule those onto your hardware is a pretty powerful concept, right? Yeah.
I think that's the beauty of a virtualization. Eh?
And Elron, thinking about that, so you've obviously, I know you've been on the call, and so you've heard Josh speak about some of the stuff they're doing around bug tracking. Would that help you with your business? Is it something, do you think many software businesses are going to find something like that useful?
Actually, while Josh was talking, I was thinking that we sometimes, like when we're building bot, we need to use some data in order to train the model of the dialog manager of the bot, for example. And sometimes we have bugs basically in the data. So if we have two different stories that we want to teach our dialog manager, but they actually contradict each other, they're very similar, but there is a small difference. We find that the models find it very hard to learn. And I think it could be extremely useful for us to find this kind of bugs or kind of duplicates in our data and not necessarily in our code.
Interesting. It's much more of a pure NLP task, right? Where you're actually looking more at English or natural language.
Yeah. I was going to say, and so many people in our comments have been talking about the data set. I always feel like with so many different solutions that we're doing with machine learning, one of the interesting pieces is kind of like, oh, using all these amazing models. And Josh, thank you for talking about the trade-offs as well between using, the latest and greatest and the new shiny versus, what do we get when we look at something a little bit more traditional machine learning. But yeah, no, it's super interesting to see everyone is focusing on the data set, right? And that it always feels like it comes back to that. Sometimes when I speak to people and they're getting into this space, that's one of the things that's maybe more confusing, where I'm like, oh, you might experiment with this first version 1 of the data set, and then you almost go back to square one. And Josh, you brought it up when you brought up the kind of diagram of the life cycle process, and saying, the exciting part, unfortunately, isn't always the bit that you get to spend the most time on. So yeah, do your research teams have to spend a lot of time cleaning up the bug data? We had someone who asked, oh, there's so many people that ask that maybe submit the same issue, but they all word it very, very differently. Like, is there a lot of cleaning that has to happen?
Yeah, so yes, the short answer is yes, a lot of cleaning for sure. So there's the issue that I brought up earlier of making sure that you have embeddings that are appropriate for the vocabulary that you're dealing with, right? So those bugs talk about VMware products, and it definitely does not look like, yes, it's all English syntax, but what they're talking about is stuff that's very foreign compared to a sort of generic vocabulary. So that has to be dealt with. But then, yeah, absolutely, things like lemmatization and stemming and all of the things that you need to do in order to reduce the text to some kind of a standard form is really important. Now, the comment about things being worded differently, that's okay, right? Because the embedding is going to help somewhat with that. The sentence level embeddings should capture some of that. And then you're doing the document similarity between the two bugs, and that's kind of the point. You want to we recognize the fact that individual engineers may describe something differently, but they're presumably describing the same thing. And so what you're trying to do with the combination of the embeddings and the distance, the similarity computation is find those ones that are actually, similar enough to be called duplicates.
Yeah, and just something then that triggered me actually as well, and someone kind of mentioned it in our comments here, the cold start problem. So the idea that VMware must create new products, and so what happens when we get to that cold start in some senses where we might not have heard of that product before? And Elron, we'll come to you for that as well, because I think that's probably relevant in your area. Sorry, Josh, you go first.
Oh, sure. Yeah, that's actually an awesome question. So, and I'm really glad you asked it. So the bug classification project that I mentioned, we are focusing on. So as I said, we have hundreds of products. That PCC, we have hundreds of products. We focus primarily on the top 10 of those products right now from a bug quantity perspective, for exactly the reason that you bring up, is that the corpus of examples that we have for, say, a new product, it's in the cold start phase, right? We just don't have enough data to actually build a credible model to actually do good predictions for that particular product. And unfortunately, it can be the case because we have a pretty far-reaching product set that what you're learning from other products may not necessarily transfer all that strongly to what's going on within that new product. And even there could be a different vocabulary, which brings up another issue. Our vocabulary changes over time. If you look at what we were talking about 10 years ago as a company internally and what we talk about now in terms of products, et cetera, it's very different. So that means that those word embeddings and the language models, those also need to be rebuilt over time as our vocabulary and our language changes over time.
Very, very good. And Elron, yeah. Oh, sorry, Sammy, you go.
No problem. Go ahead first, Elron.
Yeah, Elron, do you have cold start problems? I feel like there might be, because like a chatbot would be quite young to start off with until someone adds more data.
Can you explain again what cold start is? Sorry.
Sorry. Yeah. So cold start. Oh, good. This is a test. How do you explain cold? So
it's like when you start building a chatbot and there's not really any data yet that you can use to train your model on.
Oh wow! So it's actually very common with chatbots. Usually, what you're trying to do is to get something to run and to actually get real data from the users. Because if you're constructing all your data by yourself, it's not going to be useful in the real world. So the best thing to do is basically to create a initial data set that you can work with, and then get data from your actual users and use this data to actually teach your systems how to work more accurately.
Cool. Now I wanted to still ask a question and shoot me, it's gone. How bad is that? It's always like that.
Let's have a look. What else have we got coming in?
Well, I think one other question, like the models you are building, Josh, at VMware, you think it would be ever something that you would productize to bring public? Because I'm sure a lot of people would like to use it.
Well, that's an interesting thought. No promises here, but I think we, for those sorts of things, we actually have a track record of releasing things as flings, what we call flings, which are sort of, not products, but things that we just put out for people who'd like to take advantage of them. And also we open source things as well. So it's conceivable that we could just decide, this is an interesting enough approach here. Maybe we should just put it out for the community. Clearly, we would benefit from people, helping to improve it over time as well. It's the model that many certainly larger companies like Google and Facebook and Uber, et cetera, follow, putting things out in open source. So we wouldn't necessarily productize it, but the idea of sharing it, I think, is a pretty compelling one.
Yeah. Okay. If we go back to your session, you were talking about the amount of time it took to train your model, and you talked about VBERT XGBoost versus VBERT neural network.
Yeah.
Is it something you retrain your models like daily, or how many times do you retrain it?
Yeah, it's a good question. So that particular project has not gone into production yet. The classification one is in production. It's a good question what the frequency needs to be, for sure. I don't think we have a really good handle on that at this point.
Okay. Well, I think I can ask the same question to Elron for a chatbot. If you want to build a chatbot, the model behind it, the NLP model, how many times do you need to refresh it?
Oh, wow. So things are changing very fast, especially lately. And I feel like as someone that like wants to like your products to work the best possible, you're always trying to get to new papers written about it and try new things. And we actually often found that little tricks we read on papers or even completely different way of thinking about things help us to improve things dramatically.
Okay, cool. We have another question from the public. It's concerning if you know of any NLP tool or application that might come in the future. It might be even an ID that could, well, that could change education.
Change education. What does that mean to change education?
The way of teaching children, for example.
Oh, around NLP.
Yeah.
I guess, yeah, just anything being able to automatically interpret or like mark homework type thing,
Yeah, that
maybe.
could be a case.
Because it feels like with the bug stuff, it's like all automation, isn't it, of it? And so I think with most sectors in NLP, it feels like there's a lot to how can we very quickly understand context and kind of like aggregate context in some senses.
Aren't universities also using some kind of tools to double check if new papers are not copies of existing papers?
Plagiarism, plagiarism detection. That's a big. Actually, now that Amy has made that comment, it makes me think about another instance, and that is if, for example, you look at something like Coursera or any of the online learning platforms, right? It's not unusual that when you join one of those courses, there may be 30,000 or 50,000 people taking the same course. And if you think about, sure, how do you score things there? Well, it's one thing to have multiple choice questions, and they tend to have a high reliance on that. But if you want to allow people to have maybe more nuanced, maybe essay type answers to questions, you can imagine using an NLP to do some kind of analysis of student answers to try to understand whether or not maybe they have particular aspects of the answer that the instructor is looking for kind of embedded in some way in their response would be one thing you could do. And you would need something like that because there's no way you're going to be able to do that manually with that many people in a class.
Absolutely.
Cool. Well, Josh, thank you very much for joining us today. We were very happy to have you on board. We still wish you a very nice, pleasant afternoon, I think. You're based in Boston, so enjoy your afternoon, and we hope to speak to you another time again. Thank you very much, Josh, for joining us.
Thanks so much for inviting me. I really enjoyed myself.
Okay, cool.
Bye-bye.
See you later, Josh. Okay, so we are over to Elron. Elron, the floor is over to you. You are going to tell us, I made up the title of your session, so the story behind VerseBot, talking about some of the challenges, some of the models, and some of the different architecture choices you made. And I think this is going to be so exciting. So yeah, over to you. Please take it away.
All right. So can you see my screen?
We can.
Yep,
yes.
we can.
Yeah.
Perfect.
So this is a good start. So again, a bit more about myself. My name is Laurent Bender. I'm an NLP researcher at Byron University, and I'm very excited to be here today and tell you about VerseBot, which is a project that I really like. And instead of explaining to you what VerseBot is, I would like to show you a short video. Sorry.
You might need to stop sharing your screen.
Yeah, just a second. Let's try again. Sorry.
You want to connect with your online customers. A program that interacts with clients could be complex and expensive. Let us introduce you to VerseBot, a simple platform for genius business chatbots.
Sorry.
Search versebot.com to create your own business chatbot. Sign up and tell us about yourself with just a few details. Now you're ready to create your first friendly business chatbot. Feed your chatbot with a business description, including information customers frequently ask. The chatbot then uses this description to instantaneously assemble your own chatbot. It gets running at the speed of light. The chatbot can then be placed on your business website for use. Now, try interacting with your bot and see what needs a little tidying up. Make changes and see how your chatbot grows. You can edit your business description at any time. Your chatbot will know when human assistance is necessary. It then collects relevant contact information so you can get back to your customers' inquiries in a timely manner. Your chatbot keeps and records all connections with your customers. Visit us at versebot.com to learn more.
Okay. Sorry. Okay. So why is VerseBot even necessary? So current conversational assistant system basically use large data sets containing questions and suitable answers and plenty of stories that might come up as conversation between the chatbot and your clients. The problem with this process can be extremely expensive and long, and we wanted to make it a bit shorter and more than that, a bit more natural. So for someone that have a small business, doesn't necessarily have the right knowledge of what kind of question and answer you should choose in order to train a good model. So what we try to do is actually to decouple the business knowledge from the QA expertise. So then the business owner can just bring the business knowledge as a just plain text, and we will bring the QA expertise and we will extract the right answers from this text based on the questions being asked from the clients. So what we are trying to do is basically to create a chatbot just from text. So the problem with this method is basically that you can't really get all the information needed from a text. If you think about it, some of the chats with businesses can be very complicated. For example, if you want to call to your bank and ask for a loan, then your bank might ask you about your risk profile or about your credit or whatever. And the thing is, we can't really learn everything from text. So we try to focus on small businesses that need small operations. So the three main goals we saw in front of our eyes while developing VerseBot is that it will be extremely easy and cheap to create. It will be able to answer informative questions about a business very well. And the most important part, whenever the bot feels like it can't give you a good answer or it can't handle a situation, it will redirect you to human. And we think it's a very important part of it. So a bit about what's happening in VerseBot behind the scene. So basically we have two flows here. The first flow is the flow of the business owner, which you can see is the green flow. Whenever the business owner goes on our website, they can input our system with a description of the business. Then this description goes to our servers and stored in our database. And the most interesting flow is actually the flow of the customer of this business, the one which will actually interact with the chatbot. So this is the red flow. So number one is a question being asked, the question that the client asks the chatbot. It goes number one to our server and then straight to the dialog manager. The role of the dialog manager is to keep the state of what happened in the conversation before and then decide what will be the right way to answer this conversation. So if this conversation has nothing to do to the specific business, for example, if someone asks you, are you a real person or a chatbot? Then you can answer this question even if you don't know anything about the business. So in this kind of cases, the dialog manager can handle this conversation entirely. But then whenever someone asking about the specifics of the business, something that has to do with the specific information of the business, then we will take the information of the business in number 3 from the database. Then we will apply some pre-processing on the question and the text of the business. And then we will use a neural network to extract the answer for the question from the business text. And I will now go over every component here separately, and I'll just add that every one of them is basically operating on a completely different server as a microservice, completely independent from another. That's what helped us to try and use completely different methods and models, and I will speak about it later on. So the first part is the dialog manager. The dialog manager see that it has the history of the chat with the client, and then now he needs to decide what will be the next part of the conversation, what will be the right response. So how do you actually do it? Because basically everything the dialog manager have is just sequence of words. So how do you get sequence of words into something meaningful you can actually work with in order to find the right response? So the first step is actually to take every part of this, every sentence in this conversation, classify it as an object with a distinct meaning. For example, if the user said hi, we classify it as grid. If the user said, how are you? We classify it as an object we call mood cube, sorry. And then after we have all these objects, we can actually have a series of objects. And what we need to predict is just the next object. So then what we're doing in this case is that we have large data set of stories, which are basically sequences of objects. And then all we have to do is to find the most similar story and use this story in order to predict the next response. So how did we actually do all that? We actually used a open source Python library called Rasa. And Rasa allows you basically to train all of the models needed for a dialog manager in one place. So all you need to do is actually to construct your own data set that tells like the models how they every kind of objects should look like in a natural language form, and then all the stories you expect to see in your conversations, and then choose from the various models that Rasa offer you and train it, and in an iterative process try and improve your dialog manager. And as I mentioned before, it's very important to try and come up with a simple dialog manager and then try to get and interact with real users and see what works and what not, and then improve every part of the dialog manager. So the most important object in the first block domain is the object we called org info, which is questions about the specifics of the business. It's a question that you can answer only if you have information about the business. For example, what services do you offer? What is your address? And so on. So after we recognize this, object, we know that this is the right time to take the question and redirect it to the neural model that will help us to find the answer from the text the business owner wrote in order to describe his business. So by now, what we have is a dialogue manager that can handle conversation with no organization context. And now we know how to recognize the questions that need the organization context. And what we need to do is to find the answer from the text describing the business. So basically, you can go here in many ways. You can train a seek-to-seek neural model. You can truly go in many ways. We try many ways. I'm going to describe one which was the most successful. And obviously, if you find it interesting to want to know about the other options, you can contact me through LinkedIn or through verspot.com. So the solution we chose is extractive question answering, which is a subfield of question answering, which is a subfield of NLP. So what do you do in extractive question answering? Basically, you have input, which is a text and a question. And what you want to do is to find the most promising span in this text that will be an answer for this question. So there are actually plenty data sets that constructed just for extractive question answering. So we tried many of them, and at the very beginning, we started to notice that the ones trained on Wikipedia gave us the best accuracy while trying to predict the answers. And at a very early stage, we felt like the fact that Wikipedia contains information about so many businesses and completely different domains was very good for our problem, because basically we can't really know what business will use our service, and we wanted it to be flexible and usable for businesses coming from completely different domains. So after trying many dataset trained on Wikipedia, we found that Squad gave us the best results on a small dataset of real business description we used for evaluation. And what we basically had to do after we had the dataset of questions, text, and answers inside those texts is to train models and see what will be the best model to go with in order to find answers in our text. So what we did, we took the practically almost every state-of-the-art neural model you can find today. Most of them are transformer neural models, just because they had very good results. And just to show you one of them, for example, Spanbird has F1 of 91.9%, which means that out of the 10,000 questions in the Squad test set, it succeeded to find the area of the right answer in 90% of the cases. And then we had to think about another part of using those models, which is the production side of it. And if you want to use any of those models in production, you need to actually deploy it on a machine. And we wanted to deploy it on a CPU. We could have deployed it on GPUs, etc. But we felt like it's a bit of an overkill. We try to use the best the model that will work the best on CPU and will still give good results. So as you can see here, you can see the sizes and the speeds of those models. And we chose an ensemble of models that part of them were trained on Squad 1, part of them were trained on Squad 2. And just it's worth to mention that Squad 2 also introduced the notion of questions with no answer. So it's actually desirable in our domain sometimes to say, okay, there's no answer in this text, so then we'll want to give a suitable response instead of giving bad answer. But then we had to face a new challenge, which is Squad dataset is different in our domain in actually few ways. So the first way, the text in Squad are Wikipedia text, but when someone describing his business is not necessarily using the same language as Wikipedia. And as you probably know, if you trained neural models, the more the actual data you're using this model on similar to the data you trained them on, then the models work more accurately. So it was very important for us to find a way to get our data to look a bit more like the data or that our models were trained on. So we actually use two different ways to deal with it. The first one is domain shift. We try to change the questions a bit to look a bit more like the questions of Squad. And the other solution is to try and make the users of those models to understand better how the model works and what will make the chatbot to use the model in the best way possible. And okay, so let's move to the next, to the first solution. So domain shift. So let's look a bit at how questions in Squad look like. So for example, the first question here is, you can see from the Wikipedia value of ABC, how many affiliated stations does ABC currently have? So the subject of this question is stated explicitly, but not necessarily it will be that way when someone asks questions in our chatbot. For example, if someone asks, will you ship it to me if I buy it? What is the subject? Who is you and who is me? And more important than that, the grammatical person is completely different. And for example, the word me will never be in a text like Wikipedia, but in our type of texts, it can actually appear quite often. So what we did in order to solve it. So basically what we first tried to train a simple neural model to change the questions, to make them look more like Squad, and it didn't work good enough, and sometimes the mistakes it did make it not possible to actually use. So we actually went with more traditional way. So what we did, we actually created a set of rules of how to change questions. For example, questions like, can you send it to me? We change it, can org send it to you? And org will be whatever organization it is. So this is, so now I'll go over a real example from actually a real question someone asked our chatbot in our website, and it goes this way. So the person asked, what can you do for me? And it's very interesting here because every time it's written in our text, the word you, we refer to the customers. But here, the word you refers to us, to Verspot. So obviously the answer was something related to what the customer should do, not what we can do for it. So then when we changed the question using those rules to what can Verspot do for you, the answer was the right answer accordingly. So the pipeline for actually doing it is to break the questions into words, to sentences first, and then to words, and then to find out the words you want to replace and see if they suit to one of the rules you predefined. And then if if they fit one of those rules, just replace them, and it raised accuracy dramatically. Because now our questions look a bit more the questions of squad, and they're more related to they use the same grammatical pattern as the text we were using. So the next solution was the solution we're actually very excited about, and I'm very excited to tell you about. So the user model integration. We at the beginning, when we tried to go with this project, we thought that someone will just input a system within text and then just hope that the chatbot will be good. But then we realized that people change it quite often. And the reason people change it quite often is because they're starting to understand how the model works, and they're changing the text accordingly. And the reason they're changing the text is because they truly understand some parts of the workings of those models. And we find this concept quite interesting because usually we're thinking about neural models, something that is running on a server and the user doesn't really get to touch or to experience. And here we had sort of an opportunity to give user to experience with their own hands how neural models feel like. And we found it to be very helpful. So the first way of helping the users to get a text to be more similar to our training data was interaction with the chatbot. Then expert advice is a set of tips we supply users to actually make them construct their text in a way that will be more easy for the models to work with. And then retrospective, which is the history of the chat that the clients had with a chatbot, so they can actually see what worked and what didn't. And this is actually, it brings me to the last point I'm going to talk about today, and it's the concept of model programming by natural language. You all probably heard about GPT-3 and how amazing it works just by feeding a prompt that define the problem, give a few examples, and then GPT-3 does its magic and give you the right answer. And we actually found the same sort of process right here. So our customers giving the model basically the knowledge, and you can look at this knowledge or this text as input to the neural model, but you can actually look at it from a different perspective, because this text actually being transferred into a set of vectors representing those words, and those vectors basically interacting with the weights of the neural network. So you can look at the process of what our users do while they're changing the text, as not only changing the input for the model, but actually changing the inner workings of the models, basically just by changing the natural language knowledge that they giving to this model. Because as you can see, from every business perspective, after they find a good text that represents the business, the only thing that changes is the question, and the knowledge stays the same. So it's practically part of the neural network, and we find this concept of programming the neural network and its weights using natural language quite an exciting concept. And if you also feel you're excited about it, you can interact us, and we have many more things to say about it. So you can find us actually at verspot.com. You can create your own chatbot. Now it's not a product we actually coming out with. It's just experimental product, and we highly invite you to go to verspot.com and try and use it and see how it works. And hopefully you'll find it as exciting as we find it. Thank you.
Great. Thank you very much, Elron. Well, in the meanwhile, we already see in our comments that there are people already trying out at the moment the VerseBot. Very interesting product and approach of building a chatbot. It's something totally different than the most frameworks you see. So really nice. One question we had is around support of languages. I'm sure, well, building a chatbot in one specific language, okay, but making it available in multiple languages, how do you handle that?
Actually, it's quite a sad problem of NLP these days that most of the work's being done on English. And I'm actually a Hebrew native speaker, and it's quite sad that like we're not there yet in low resource languages. And hopefully, many people actually work on bringing those amazing new models to low resource languages, and it's still in progress, and would love to see more progress in it and combine many languages as much as possible.
Okay. Now, if we're writing or even when we're speaking, I'm not a native English speaker, as you might hear. We make mistakes. We make writing mistakes. We speak out wrong things. How do you handle that in your project, for example?
So actually, it's a very good question, because we tried many type of grammatical mistakes and even spelling mistakes, and try to see how our system deal with it. And the very interesting thing we found is that models that are not trying to detect if the question is answerable, which means that it has an answer in the text, they do better in environment which things are not very clear. So they actually can generalize better to poor language or to different domains than the training data.
Okay, cool. Now, when you're training different models, you'll have specific data sets that you're using. How do you manage versioning of that to make sure you have to make improvements of it for A/B testing and so on?
So it was, in terms of our data, we try to actually keep records of what we did in every stage, and we just used a simple Git system to do it, and we find it very useful. And in terms of academic data sets, we had lots of insights about them that we also documented in order to get the most out of them.
All right.
That's really cool. I have a quick question for you, Elron. You might have mentioned it, I feel, but I just want to clarify. So you've added in the language models, the knowledge base is kind of the core, and it's the question that is going to kind of frequently change. But what if someone just asks something completely out of context? And we know that people do that with chatbots.
Yeah, so we handle it in two different levels. So first, in the level of the dialogue manager, we have basically a data set of questions which are completely irrelevant, chit chat, bad language, or everything you can think about, and it's supposed to detect this kind of language and give a response accordingly. And the other part is when someone is asking questions that cannot be answered by the text, then our neural model actually produce certainty probability that help us to know how accurate the question is and how much the question can be answered by the text.
Very nice. No, that's interesting. And yeah, kind of thinking about how to handle all those. It's almost like exceptions, it feels like, in code. Like, how are you going to handle them when they hit the not the actual design of how you think people will use chatbots? That's super interesting.
Now, in the parts we've seen already, it's mostly you have a question and you give an answer back. Any plans to also add actions to it?
So the only actions we have now is to collect clients' information when we feel like the bot is not doing well or there is something the bot can't really do. So the actions we do there is to collect the client information and pass it on to the bot owner. But obviously we thought about it and we're still thinking about it, how to combine new actions and new skills to this chatbot. And at the same time, we want it still to be generic and to suit many kind of businesses. And you truly need to think about it. It's not an easy problem.
Okay, cool. Elron, thank you very much for your time today.
Thank you for having me.
All the best with your product VerseBot. We're looking forward to the next iterations of it, what all the things it will do. So enjoy the rest of your evening. For you, it's still an evening, if I'm correct. And we will invite our third guest for today already, Vered Schwartz. And we'll have a little issue, but that will be fixed very soon.
Hi.
Hi,
Hi,
Vered.
Jared.
We're not seeing you yet on the screen. There
Here
you
we
are.
go. There we are.
Great. How are you?
I'm good. How are you?
I'm fine. We're very glad to have you also on board today for the October sessions. Please introduce yourself to the public. Who are you?
So I'm a postdoctoral researcher at the Allen Institute for AI and also in the University of Washington. I'm working on NLP, or more specifically, recently working on teaching machines common sense reasoning.
Okay, cool. Can you tell us something short about the Allen Institute?
Sure. So it's a nonprofit organization for doing AI for good, mainly doing NLP, but we also have a vision team and doing a lot of very cool work.
So you're glad you can be there. Cool. What are you going to discuss with us today?
So I'm going to talk about the things that work or don't yet work in NLP today, which is mostly deep learning based.
Okay, cool. Well, with that, I give you the platform, and we are listening with open ears.
Okay, can you see my screen?
Just give it one moment, and I'm sure we will. Oh, people are asking, what is the raccoon called? The raccoon on next to Sammy is called Bit, as in like
it's wrong camera.
Bit, 100. Yeah, it's a bit of a friendly mascot of this community, which is a treat.
Exactly. And before we forget, also, please send out some tweets. If you go to globalai.live/ what was the link again? Win-action. It will be added in the chat also. If you add a link to your tweet, we will pick someone randomly, and then you can win a voucher of $50 for Amazon. So go ahead and try to win it.
Okay, we're having a little problem. Derek, could you try and restore your screen for us?
Sure.
Let's see if we can. This is I mean, we're doing pretty well. What are we, like an hour and a half in, and this has been the first technical glitch. Here we go. Is that it? Right? So I can see it. Hank, are you able to do some magic and so that everyone else can see it? Yes, there we go.
Okay.
We all see it. There we go, Vered. Please take it away.
Great, thank you. Okay, so I'm going to talk about recent breakthroughs and uphill battles in NLP. So if you get most of your AI updates from popular media, then you might get the wrong idea that language is already solved, and that moreover, robots are pretty dangerous. And you would get that from headlines like Google's BERT understands language better than humans, or various paraphrases on AI beats humans, and some famous stories like Facebook had to shut down AI that invented its own language, or OpenAI refusing to release its model, claiming it's too dangerous to release. There's also some funny examples, like this one from the end of last year, where GPT-2, OpenAI's model, was used to predict the future or the world in 2020. And it was unfortunately very wrong. Otherwise, it would have been a much nicer year. Inside the field, we measure progress using leaderboards that contain various NLP tasks. And they also are a bit misleading because it seems like we are at human level or even above human level on various complex tasks. But that's not quite the case, and that's what I'm going to talk about today.
Hey, Vera, sorry to interrupt. I think we might be seeing a different screen. Are you advancing slides? Are you advancing? Are you changing to different slides? It's changed now, but that was the first time it moved. So I think we might have missed a picture.
I'm just going to share the entire screen. Sorry about this.
No worries, no problem.
Do you see it now?
Yes. Yeah,
okay.
I believe so. Yeah, that's better.
Yeah. Hopefully it's going to work now. Okay. And if you work on NLP in industry, or if you're just a user of NLP, and most of you are, then you should know that some things work reasonably well in practice, and specifically for English, but not always so for other languages. So I personally use autocomplete, grammar corrections, search, and translation, which work very well for or reasonably well for me in English. But I'm also a native Hebrew speaker, and these things don't really work well in Hebrew, or not as well as they work for English. So the reason that these models work well today is mostly due to the decoder architecture, or SIG-to-SIG, as it was referred to in one of the earlier talks, where you can take a task that requires translating an input sequence into an output sequence, such as, let's say, for example, translating from English to Spanish. So you would take a sequence of English words like the white cat, and then encode it using the encoder into some vector representation. And then the decoder decodes this word by word, outputting the Spanish translation, which would be El Gato Blanco. And so this is not just limited to translation. It works well for other tasks that are in a similar nature, such as grammatical error correction, email response suggestions, which I really like and use a lot, or image captioning, where the input sequence is not necessarily, it's not a text, it's an image. And with partial success also for summarization. So encoder-decoder models are very efficient for tasks that require learning some mapping between input sequence and output sequences. But that's given that they have enough training data. So let's talk about these enough training examples. And I'm going to get a bit hand-wavy here. And I want to make the claim that humans generalize from few examples. So for example, if you show a child a picture of a cat, and you tell them that the cat eats, then they're going to build some abstract cat representation in their head. And then upon seeing the cat doing other things, they can generalize and say, okay, here the cat drinks, or the cat sleeps, or maybe seeing a different cat and still being able to tell that the cat eats. This is not quite the case with machines, where if you just trained an image captioning model with one example, it's going to be pretty helpless in captioning similar images. What you would do instead is you would provide it with multiple examples. So in this case, it's going to be multiple images of different cats eating in different angles. And then these models can do pretty well. So the problem is that models are data hungry. And for this reason, specifically, these applications mostly work well in production for English, which is a high resource language. But they don't always work as well for languages with enough training data. So one good example for that is translation. And here's where you can see where NLP for other languages is even less solved than for English. So here's a chart from one of Google's papers that shows the number of training examples for different pairs of languages. So the higher resource languages, they have almost 2 billion examples, whereas the lower resource languages, they can have even just around tens of thousands. So it's a major difference. So what happens when there's little training data? So here's something that happened 2 years ago, which has been fixed by now, but I think it's a good demonstration nevertheless. So Google Translate was generating religious prophecies, and here's an example that I kept from 2018, where before this bug was fixed. And what I did here is I set the input language to Igbo, which is a low resource language that I'm not a speaker of. And I just inputted some nonsensical sequence of eyes and spaces, which I'm pretty sure is not an Igbo utterance. By setting the translation to English, what you would expect to happen is the model to tell you, this doesn't look like a valid Igbo input. I don't know what to do with it. But this is not how neural models work. And what they do instead when they don't know the answer is they just try to still answer somehow by generating something that's similar to their training data. And what was generated here was the English translation was, as it is written in the book of the law of Moses, which was in the wilderness, which was before the man who did the work in the kingdom of Israel, which I'm pretty sure is not what I wrote. The reason that this is biblical is likely because the way that machine translation works is that it's trained on parallel texts saying the same thing but in different languages, which are usually obtained by human translations. And it's likely that there was not enough data for Igbo English translations, but something that is often available in across multiple languages is the Bible. That is pretty much the lowest common denominator of parallel data. So it's likely that the vast majority of the Igbo English model training data came from the Bible. So models fail to generalize to out-of-domain examples, and even worse than that, they don't know to tell you when something is out of domain, but they still try to answer the question. So the solution is that when it's possible, you don't train these models from scratch, but instead you continue training a pre-trained model. So this has been happening in the vision community for quite a while now, and in the last 2.5 years, we've been doing that in NLP as well. And if you've heard about all these models with the Sesame Street character names, this is what we're talking about. These are the pre-trained language models. So what is a pre-trained language model? A language model, standard left to right language model traditionally is, so language models in general are trained in a self-supervised manner on a large text corpus. And standard left to right language models are trained by predicting the next word in a sequence. So for example, in this sentence, parrots are among the most intelligent birds, and the ability of some species to imitate human speech enhances their popularity as, so we need the model to predict pets. There's a second variant called masked language model, in which you don't have to predict the last word, but you can instead just mask out some word in the sequence and try to restore it. So this is what happens during the pre-training step. And what you typically would do is that you would take these pre-trained models and you would fine-tune them. Keep training them on a different task, your task of interest. And you would compute the task-specific loss and then back-propagate it to update the representation. So pre-trained language models are trained once and then fine-tuned for each task with pretty tremendous success across NLP tasks, with potentially needing fewer training examples for the specific task because the model already has a lot of knowledge. The problem is that it's not like someone trained one language model and then we all just used it and moved on to other research problems. But instead, this has become this competition between the large research groups on which one of them would train the best language model. And the best language model correlates with an increased number of parameters. So just 2.5 years ago, the Elmo model contained 94 million parameters, which was also already quite big for the time. But now recently, Google announced its G-Shard model, which has 600 billion parameters. And consequently, this has become very expensive to train such models, where OpenAI latest model, GPT-3, is estimated to have cost $12 million to train. And this is obviously not a cost that all research groups want or are capable of investing. And it's also not very clear that the effort, that the cost and the effort is really worth it, because if you look at the standard leaderboards, you can see that there is still slight improvement from one model to the other, but it's pretty much reaching the point of diminishing returns, where the gaps between the different models, the accuracy gaps are pretty small and definitely not proportional to the increase in parameters or in training cost. And it's already beating humans on most of these tasks. And finally, it's also not very friendly to the environment, as it was mentioned in the talk by Josh earlier. So last year there was a paper that showed estimated the CO2 emissions from training common NLP models and compared it with familiar consumption. And this was even before the very large models, but it was already painting a pretty concerning picture. So these models are huge and they're computationally expensive to train and use. And on that note, I would add that I am co-organizing a workshop called SustainLP, which will be held next month virtually at EMNLP, where we encourage building simpler and more efficient NLP models. So please participate. Okay, moving on to the different type of tasks, which is the more complex tasks that require deeper understanding. So I want to show an example of a real-world question answering system. This is a demo that someone shared with me, and I don't mean to say anything bad specifically about this system. I just want to show how incredibly difficult this task is. So this is a demo meant to answer questions about COVID-19. And I asked it about the risk of COVID-19 infection from touching public surfaces. And it's likely that it doesn't actually contain the answer for that, but what I got in return were actually answers for different questions. So, for example, what is the probability of transmission of the virus from Wuhan to other cities in China before the quarantine? What is the risk of getting infected by children? What is the ability to detect imported cases among high surveillance locations? And finally, the only paragraph that seems somewhat relevant is the last one, but it still doesn't answer the question. So this is to illustrate the difference between solving a task, like question answering, which is incredibly complex, to solving a data set, which is something we do pretty well today. And now let me show you an example of solving a data set. This is for a different task called natural language inference, or NLI. So in this task, the model is given two sentences, a premise and a hypothesis. The premise is known to have happened, and the goal is to determine the truth value of the hypothesis. So for example, for the premise, street performer is doing his act for kids. We can have the hypothesis, a person performing for children on the street, which is considered entailed because it's not adding any new information. This is pretty much repeating the premise, but making it a bit more general. A juggler entertaining a group of children on the street is neutral because it may be true, but we don't know for sure that the street performer is a juggler, so it's adding information. And finally, a magician performing for an audience in a nightclub is considered contradicting because, assuming we discuss the same events, one of them happens on the street while the other one happens in a nightclub. If you didn't understand the task, that's perfectly fine. This is a pretty complicated task that requires knowledge about word meanings, understanding of syntax, ability to resolve references to entities, word knowledge, and common sense reasoning. Yet, the best neural models today already beat humans or are at human level on these on the standard data sets for the task. So why is this happening? Is it because they actually solve the NLI task? Not so much. It's because they solve the data sets, and they do that by finding these shallow patterns of that correlate between the inputs and the outputs in the data set, which are not always indicative of the task. And one pretty neat way to show that, it has been shown 2 years ago by 2 papers, is that if you provide a model with just a part of the input, just the hypothesis, it's still doing better, much better than chance. Whereas the human provided just the hypothesis would not be able to solve the instance. So what it learns are things like that if the hypothesis contains a word like outside, which is pretty general, then it's likely entailing, while longer hypotheses indicate neutral because usually you would add information. Or this one is my absolute favorite. The existence of the word cat in the hypothesis correlates with contradiction because the premises in the data set were taken from image captions and they contain a lot of dogs. And as you all know, cat is the opposite of dog. So models rely on shallow patterns or spurious correlations, and they fail to generalize outside their training domain. These patterns are often not very indicative of the task itself. They're just indicative of the data set. Specifically on the NLI example, the reason that this happens is because the data set is somewhat artificial. So the way it was built is that the premises were taken from image captions, but then crowdsourcing workers were asked to generate the entailing, neutral, and contradicting hypothesis. And what they likely did, which is what everyone would do if they had to answer a lot of tasks and they get paid by task, is to come up with these cognitive shortcuts or strategies to answer as many questions as fast as possible. So, for example, replacing dogs by cats or adding negation to contradict the sentence. And these things are incredibly easy for neural model to pick up on. Another problem is that it's hard to tell whether a model learned valid or spurious patterns for a specific task because neural models are just not interpretable. And this leads to a different problem, which is even worse, which is fairness problems, where our machine learning models, they learn our bad habits and our biases from us, and it's very hard to find it. So here's just a handful of examples from many examples over the last few years. So for example, Microsoft chatbot that became racist in one day, or lots of gender bias and racial bias in various applications. There's also the example of Amazon that built a tool meant to filter out CVs for recruiting purposes, but it couldn't actually use it in practice because they found it was discriminating against women. So neural models perpetuate social biases that are found in their training data. Let's look at the Amazon CV filtering example and try to figure out what could go wrong. So if you had to build a CV filtering system, what you would usually do is you would build a data set that's based on past decisions made by people. So you would take the CVs that were sent for applications, and then the decisions that the responsible person decided whether to go forward with them or not. The problem is that the people that provide these supervisions are likely biased. So it may be, for example, that in this specific case, someone thought that men are better qualified for some job than women. It's also likely that there were not enough women in the training data. The second problem is that, as I've mentioned, we use pre-trained representations. So these representations are also biased. And so, for example, it has been shown that for word representations, they contain racial and gender biases. So, for example, a programmer would be considered more semantically similar to men than to women, which is more similar to homemaker. And once we use these representations in our systems, it just amplifies the biases. And finally, as I've mentioned, since these neural models are not interpretable, it's pretty hard to actually figure out that you have this system that amplifies biases, unless you specifically probe it by, for example, providing it with two identical CVs that would only be different in the gender of the applicant, and then seeing whether the predictions are consistent or not. Moving on to a different topic, this is the positive one, dynamic versus static word vectors. I think this was also mentioned earlier today. So the way that we obtain word just to mention first that obviously word have multiple meanings, and the way that we obtain word representations today reflects that. So we use language models which take into account the entire context that the word is found in. So, for example, in a sentence like "I'm using both the keyboard and the mouse," the representation would be dynamically built for the sentence, and it would reflect the computer device sense of mouse. While in a sentence like "the cat chased away the mouse," it's going to tend more towards the animal sense. This is different from only about 2 years ago, where it was pretty customary to use static embeddings. So you would just retrieve the single embedding for mouse, which would, in a weird way, senses, and then it would be up to your downstream application to take care of distinguishing these two senses, if you do that at all. So finally, most of NLP research is context sensitive. This is really great news. This is using the transformer architecture in most models today, but it's not the only context-sensitive representation, but it's the dominant one right now. And the way that it works is that, largely speaking, every item in a sequence is represented as the average of the deep representation of all the other items in a sequence. But modeling context is hardly enough, and there's so much more than that these text representations don't really capture today. So, for example, things like implicit meaning. If I say that I didn't eat anything since the morning, then I likely mean that I'm hungry. Or broader context, like an utterance like "no thanks" on its own is not very meaningful, but in that context, it can mean something like "I refuse to offer food." Or non-literal meanings. So I could eat a horse doesn't actually mean that I would eat a horse if I had the opportunity. It just means that I'm really hungry. Pragmatics, so things like "do you have some food here?" is just a polite way to ask for some. And common background. So if I tell you there's a new restaurant in the city, I likely refer to the city we're in now. And I keep using this example in virtual conferences. I realize it's a bit strange, but yeah. Yeah, this gets even more complicated because in the US, depending on where you are or where you're from, if you say the city, there is a whole convention of which city you refer to. It doesn't even have to be the city you're in now. And all these complicated things are not really represented very well in these representations, which hardly capture any meaning under the surface. Do these text representations have common sense knowledge? So the answer here is mixed. So on the one hand, it's possible to extract knowledge from language models. So for example, if you provide it with facts or candidate facts, you can score them to see which ones of them are more plausible or more likely to be correct than others. Or they're also capable of associating concepts with their prominent properties. So, for example, a lion has fur, is big, and has claws. And they're pretty good at generating definitions and properties of concepts. On the other hand, the knowledge that they generate is not very reliable. It's not very accurate. And there's a whole line of work right now showing all the limitations of these models. So, for example, they are not very sensitive to negation, so they can score facts like birds can fly and birds can't fly almost equally likely. They also have these really weird generalizations. So, for example, they can generate something like Barack's wife Hillary because they just know that these two names are somehow semantically similar, but they don't really know how to express the specific semantic relation between them. And this is a similar phenomenon. So in certain constructs, they know that they should predict the color, for example. So the something banana is tasty, but they don't necessarily know what's the color of a banana. So they just output different colors. And they are also sensitive to the phrasing. So they would provide different answers if you try to complete a sentence like, the sky is something today, as opposed to today the sky is something. So the representations lack sufficient common sense. And the root of the problem is in reporting bias, which is, or at least some of the root of the problem is in reporting bias, where the problem is that we tend to talk more about the sensational and noteworthy things than the trivial things. So text corpora hardly contain any very trivial things. And then it has been shown like a few years back that if you look at the frequency of people's actions in text, you might conclude that people murder more than they breathe. The reason that this happens is because you wouldn't find reports or news reports or any discussion on the internet on people breathing. And language models, they don't really solve this problem completely, and in some ways they even amplify it. So the way forward might be to learn from additional modalities, not just from text, but also from vision or from images or from videos. So, for example, aggregating across similar images, you might learn that in a class photo, if someone is in the front row, then they are likely seated, maybe cross-legged, while if they are on the last row, then they are likely standing, otherwise they wouldn't be seen. To conclude, let's go over the checklist of what we want our models to do. So we want them to seamlessly learn input-output mappings. We don't want to train them from scratch every time, and we want them to be context sensitive. This is pretty much solved. But we also want them to use fewer training examples, to generalize outside our training domain, to be smaller, to solve the task instead of learning data-specific shortcuts, to be interpretable, not to perpetuate social biases, to capture meaning under the surface, to capture accurate common sense knowledge. Yeah, that's it. And this is pretty much all still work in progress. Thank you.
Oh, wow. That was amazing, Vered. And also that sort of end checklist looks a bit like my general to-do list. Like it always feels like you're just doing the top few and then you're like, oh, there's so much more we need to do in this space. So thank you so much for sharing that. We actually have some really great questions in the chat, but please hold those as a thought. And what we're going to do is we're going to go through our last and final talk, and then we'll bring back Vered along with our next speaker, and we'll have a really, really good conversation and hopefully get all those questions answered. So thank you so much, Vered. If you can hang around for a little bit longer with us, we're very excited to speak to you again.
Thanks.
Amazing. So next person up is Ines Montani. Some of you may know her as the founder of Explosion and also one of the core contributors to Spacey, which is an incredibly popular package to use when looking at natural language processing. So welcome, Ines. Hey. Can you hear us okay?
Sorry, I think I was muted, but I think I can.
Now we
hear
can
me
hear
now.
you loud and clear.
I was
Perfect.
going to say, it is not a conference call or an online event unless we go, you're muted. Can you unmute?
No, also people always assume that because I live in a big city, I have a great internet connection, which is absolutely not the case in Germany. So
it's so hit and miss, isn't it? And also I find times of the day, someone in the comments, let me know if this is actually true of my Wi-Fi, but I feel like the minute people like stop work, which tends to be, I work a lot with the US, and being from the UK, that means my evenings are quite full.
yeah,
oh my
I'm exactly the same. Yeah.
It's so bad, isn't it? And
But
then
hey,
I'm like,
it's Netflix time right now, so everyone is consuming the network.
I honestly think that's what it is. Yeah.
Fantastic. Well, Inez, can you introduce yourself? I don't think I did you justice. So if you can just tell us a little bit about yourself.
Oh, I mean, I think you did. I really like the introduction, because I usually start my introduction with like, "Hi, I'm Inez. Some of you might know me from my work on Spacey." So that was actually that's exactly what I would have said. So, but yeah, I'm the co-founder of a company called Explosion, and we specialize in developer tools for machine learning and NLP. And yeah, Spacey is probably our most popular open source library, but we also do a bunch of other stuff. We publish a data annotation tool called Prodigy, which helps users really create their own data sets and also, work against some of the problems that we also just heard about in the previous talk. So yeah, that's what we do. And we just released a new version of Spacey, well, the pre-release, a nightly version people can try out. So that's also what I'm going to be talking about today. And it's the first time I'm talking about this at any conference. So this is quite special.
Oh my goodness, we have an
all
exclusive.
For global AI. We need to be fair with the speakers, with the viewers. Inez, her session is pre-recorded because of the network that is not always so stable. So let's, I think let's have a look at it, right?
Hi, I'm Inez. I'm the co-founder of Explosion and a co-developer of Spacey, a popular open source library for natural language processing in Python. Spacey helps you build advanced natural language understanding pipelines using the latest state-of-the-art machine learning techniques, as well as fully custom and rule-based approaches for your very specific use case. Spacey has come a long way since its first release in 2015. It's been downloaded over 20 million times with a large community and ecosystem. What makes Spacey special is that it was designed for production use from day one. This also means that we think about a lot of things that aren't really relevant to experiment code. Like, we make sure the library is easy to deploy and practical to run on lots of text, and we also focus on the developer experience, like getting the right conceptual model behind the API, consistent naming, good error handling, and great documentation. Version 3 of Spacey brings a whole new level of this. New transformer-based pipelines that get Spacey's accuracy right up to the current state-of-the-art. Training is now fully configurable from start to finish, and the new Spacey projects let you manage end-to-end workflows from prototype to production. Transformer models are a family of neural network architectures that have proven very successful for NLP, especially when used with language model pre-training. The most important advantage of transformer models is that they scale up better. As you add more parameters, transformers keep improving more steadily than earlier alternatives like the CNN or LSTM. Transformers also use GPU architectures more efficiently, and GPUs have been getting more powerful, while CPUs have been kind of stagnant. So, while we keep getting new boundary-pushing transformer models that are a bit too big for many practical purposes, like NVIDIA's Megatron or OpenAI's GPT-3, models like BERT-based that felt quite extravagant a few years ago now feel pretty practical given how GPU prices have been falling. So, with all that context in mind, we're pleased to introduce a new family of trained pipelines based on transformer architectures. The pipelines run best on GPU, and you'll definitely want a GPU for training, but you can also deploy them on CPU. Under the hood, the transformer-based pipelines use the Hugging Face Transformers library and PyTorch, so you can use any PyTorch-based model that Hugging Face publish very easily and out of the box. For the English transformer pipeline, we used a Roberta-based model that was published by researchers at Facebook shortly after the seminal BERT paper by Devlin et al., which showed the success of language model pre-training for large transformers. We fine-tuned the Roberta-based transformer for all of the tasks in the pipeline, like that includes dependency parsing, part-of-speech tagging, and named entity recognition. We're really happy with the accuracies we've been able to achieve so far with the transformer-based pipelines. Using this approach, SPACY's NER accuracy is now right up there with the current state-of-the-art, and the other components also get accuracies that are up to date with modern systems as well. There are definitely trade-offs with the transformer-based pipelines though. There are more dependencies, GPUs are more expensive and less reliable, and latency can also be a problem. On the other hand, the system does make 30% fewer errors across these tasks, which can definitely be important. So if you find yourself working on something and accuracy really is the main blocker for you, you should definitely consider trying out the transformer. The transformer support in SPACY 3 is also very flexible, so you can build your own solutions. You're not limited to just the pipelines that we've trained and distributed, and probably the feature that's most important is the ability to put the transformer weights into their own component, which other components in your pipeline will then be able to connect to. This makes it really easy to do multitask learning, and it's how we have one transformer powering the tagger, parser, and NER all at once. It makes a big difference for your performance because the transformer only has to run once, even if your pipeline consists of a lot of separate components. We've also made sure that the transformer-based pipelines behave just the way you'd expect other SPACY pipelines to work, when it comes to things like saving, loading, and installing the train pipeline, for example. The transformer-based pipelines saved out the fine-tuned weights into the directory for you. So the directory is fully self-contained, you can test your artifacts, and when you're deploying the model, you don't have to worry about your workers downloading things at runtime. And if you package the model using the SPACY package command, it can be installed via pip, and the requirements will all be specified for you, making installation really, really easy. Transformer-based pipelines are really an example of a relatively complex way to arrange your pipeline. The transformer itself introduces a number of options, and then you have the other components that need to connect to the transformer and set up their other options. And there are many ways for this configuration to be wrong, resulting in a pipeline that can't run or won't learn anything useful. And the fact is, this is all really standard for machine learning, of course. SPACY is definitely not the only library that has to think about this. Every machine learning system is sitting on a big pile of configuration, always one flag away from blowing up and ruining everything. And the problem is pretty fundamental. It's what deep learning is, if you think about it. The whole premise or the whole promise of deep learning is that we can stack a relatively small number of layers or layer types together to create complex systems. And then the optimization process introduces even more settings, and we're constantly tweaking the dynamics to try and guide the model to better solutions. So settings everywhere. And we've definitely felt the pain of letting these settings get out of control, and we think it's really an important problem. So we've also put a lot of work into getting SPACY set up to really do this right. So here's an example of a common problem that arises from configuration settings. It's really common to pass in configuration that gets passed from one function into another. Of course, each of those functions have to have a usable API, so they're likely going to have default values. And passing all those defaults along is really, really error prone. It's hard to figure out where some value is getting injected, and it's hard to keep all the defaults aligned. And you're also exposing a lot of details of the functions you're calling into the outer API, which really ties into that one type of object it's constructing. So if you later add the option to create a CNN or transformer here instead of an LSTM, you'll have a bunch of options that are only valid in some situations. And that's when signatures really get out of control, and your editor starts giving you those whole screen tooltips that nobody really wants to see. So Here's an example snippet of Spacey's configuration. It's based on Python's built-in config parser module with a few extensions that we wrote specifically for it. One is that we use JSON to parse the values, so you can easily make the values lists or mappings using a simple and also familiar syntax that you probably use in other places as well. And second, we follow Toml's convention of using a dot notation in the section names to denote nested section. And this keeps each block simple and readable and avoids the indentation problems that can arise in very long config files. And we're really happy with these syntactic conventions, and we think the resulting config stays pretty neat and easy to read. But the thing that we're really proud of in the config system is the whole system itself and the whole way it works and what it does. Because what really sets it apart, I think, is the registered functions integration. Your config file can describe a function or function call or object creation by referring to a function that will then be retrieved from an extensible table that we term the registry. So in this example, the registry will look in its optimizers table for a function named according to the specified key, Adam v1. This function will then be called with the other elements of the block passed in as arguments. In this example, the other argument is the learning rate, which is also created via a registered function. The configuration is resolved bottom up, so the result of that function is computed and the resulting object is passed into Adam. In this example, the learning rate here will come from the schedules table, and it will actually be a generator. So I know that's a lot to take in, but I really think it's worth taking a second here. What we're doing here is letting the tree of objects get built bottom up instead of top down. In a normal config system, you'd pass the optimizer settings for the learning rate, and the optimizer would then go and construct the object. So all the config goes into the object at the top of the tree and travels downwards, getting passed along the call chain. Instead, here, each object only receives the configuration it needs itself, because it doesn't need to create any objects. It just gets the object instances. And this is achieved by the simple mechanism of having a registry system, so you can refer to functions by name. Of course, the registry system wouldn't be much fun if you couldn't also add things to it yourself. So you're not limited to just the functions rewrite and register for you. It's really easy to register your own functions using the decorator. Behind the scenes, the config system does a lot of cool stuff for you. It looks at your function signature and uses it to build a pedantic data model that can be used to validate your config. So if your config specifies arguments that would result in an error like wrong names, missing required values, even type errors like passing a string instead of an int, we can raise an error message for you right away. So we don't need to run everything and let you see some weird traceback 5 minutes later just because you made some typo. The CLI also adds a few cool features that really improve the developer experience around this, I think. You can quickly set up a new config file using the recommended defaults given the pipeline you're trying to train. And you can even tell it about the trade-offs that are relevant to you. So it can recommend you a config that's tuned for accuracy rather than just efficiency and speed, or vice versa. And once your config is ready, you can then pass it as an argument to the Spacey train command. And the config system is another step in the CLI experience that we've been building for Spacey for quite some time now. And you can define your pipeline in the config system and then execute the training with a simple and consistent command, while still being able to change things on the command line if your workflow requires it. And once the model is trained, it can be converted into a Python package, which gives you a really easy way to ship it and deploy it into production. And as you can see here, machine learning projects inherently consist of several steps. Even in the simplest case, you're going to run some sort of training process, save out the trained model, and then you'll be loading it back in to predict with it. And in practice, there are usually many more steps in the process. Like you might need to go over the corpus before you create your models in order to build a vocabulary list. Or you might need to run some sort of data conversion, pre-processing, or augmentation step. And your project might not consist of just one model. Maybe you're doing something like aspect-oriented sentiment analysis and only 0.5% of your texts are even relevant. So you need to train and run a text classifier first to find the stuff that's on topic. Or maybe you're doing a dialog task and you need many layers of analysis. The new Spacey project system helps you keep those multi-stage projects organized. And we're especially excited about how much easier this makes it to share and reuse work. Instead of everyone having to write their own scripts and instructions to run the various steps in their repo, we can just all use a common standard. And for the most common workflows, like training a named entity recognizer, you'll be able to clone our project templates, modify them for your data and requirements, and then just run the commands. And then when it's time to ship your work into production, you'll have everything in a format that's super easy to automate and just run and deploy. So here's what we expect everyday usage to look like. Once you found a project template you want to work from, you can use the Spacey project clone command to create a local copy, just like git clone. At this point, you might want to edit the project template to point to your own data files or customize the template to better fit to your requirements in some other way. And next, you'll run the Spacey project assets command to download or verify the data required by the project. Project templates can point to assets hosted in lots of different ways. They can be behind a URL, they can be in a Git repo, or you can also describe assets without a source URL. You'll still need to get those into the right place yourself, but at least you'll know when they're missing, and if the project template specifies a checksum, it can also tell you whether you're working from the right version. And once you have the assets, you'll usually use the Spacey project run command to execute a command or workflow, where a workflow is just a list of separate commands. As the steps are completed, the checksums of the outputs are saved out for you to a little metadata file, and this helps you replicate your work later. And also makes it easy for Spacey to check whether some step can be skipped. Probably the biggest inspiration for the Spacey project system was DVC, data version control. There's even an integration for DVC users to make it easy to use the two together. Integrations work really well within the Spacey project system because many tools in the ecosystem operate outside of your local Python installation. They're often services that help you fill in various parts of your workflow. For instance, when you're training a model and running different experiments, you typically want to track the results. Weights and biases is a popular tool for this, and Spacey integrates with it out of the box, using a logger that you can add to your training config. It will log the entire config, including all settings, hyperparameters, and even registered functions, so you always have a record of how your model was trained and how the different settings impact the results. Once you've finished training a model, you can also spin up an interactive Streamlit app to explore its predictions or compare it to other pipelines. Our Spacey Streamlit package provides building blocks for visualizing different components. You can also use it as a step in your project. So you can run Spacey project run visualize to spin up an app with a pipeline trained in a previous step. The projects and config systems work together to let you set up and train powerful language understanding systems. And here a pipeline is a sequence of components. And you can think of it like an assembly line. The doc object travels along it, and each component does its little bit of work updating the doc with new annotations. And at the end, the doc API stores the annotations efficiently and makes it easy to use the different annotations together. Here's part of a config file that describes some pipeline components. The NLP object will look up a factory function using this string name and create it with the arguments defined in the config. A subsection like model is just another argument, and here it uses a model architecture created via the function registry system that I talked about earlier. This example creates a transition-based named entity recognizer, and its model's token-to-vector embedding layer is a transformer listener, which connects to the transformer component in the pipeline and allows multiple components to share the same transformer embeddings. The talk-to-vec layer also takes a pooling layer as an argument, in this case reduce mean for mean pooling. All of these are things you can customize. You could, for instance, change the component to use a bi-LSTM instead of a transformer, or you could change the final pooling strategy so that only the first word piece token is used, rather than the average. You can also implement entirely custom models. For instance, you might make a sparse linear model like we had in Spacey version 1, Or you can register an entirely new component. For instance, maybe you want a CRF-based named entity recognizer rather than the transition-based approach. Just as with normal code, it's extensible in several places, and you can choose the abstraction at which you want to get involved. You can also reuse the weights or configuration of a component from another pipeline as a starting point. This can be useful to kind of import pipeline components into a new pipeline, or to do things like domain adaptation or self-training. If you just want to import a component, for instance, to reuse a named entity recognizer in a new text classification project, you can set the component weights to frozen. This tells Spacey not to treat the components as usual and to try to update it. And this way we can make sure that you can use the Spacey train command in really most situations. There's also callbacks for different points in the life cycle. If you really need to train from code and want to, you can definitely do that. And the abstractions here are easy to use too. But generally, the Spacey train command should really have you covered. For train components, the most important type of customization you'll want to do is, of course, the model. Spacey can communicate with models defined in major frameworks like PyTorch, TensorFlow, and MXNet via our machine learning library Think. This was a key design goal we had for Think. It works as an interface layer between Spacey and other machine learning libraries by wrapping their models and acting as a shim. For example, Think's PyTorch wrapper layer takes a PyTorch model and returns a Think model instance. You can then use it inside your registered functions to build up the Think model and then use that to power your Spacey components. So yeah, that's what's in Spacey 3 and why it's there. And we've been learning a lot from helping Spacey grow and evolve the last 5 years. And we've actually really been looking forward to sharing this all with you. And one of the aspects of Spacey that we're most proud of is the really awesome ecosystem of plugins and extensions that's grown up around the library, with so many awesome people developing these things and publishing them and helping other users in their NLP projects. And now with all the new features and configurability, we're really looking forward to seeing the ecosystem evolve even further. So I'll hope you try it out and definitely let us know what you built.
Amazing.
We're really I'm sure many people are looking forward to try out this new version of Spacey. And as you might see, Ines' connection goes up and on and off. So
yeah, actually, I'm so glad I pre-recorded this because literally like 10 minutes in, my internet connection dropped out. And imagine this had happened live. I mean, for me, it's more like, if I do something, I want to do it properly. Like, I don't think, I either do it properly or not at all. And I think this was the best value for whoever is currently watching this.
We are looking forward to try it out with all the new features that have been added to the library. We had some questions from the public, and one is, are you working on making your Spacey like explainable?
You mean as in adding features that help people?
Why does it make that decision?
We actually, so I think that actually could be a really great extension now with, the sort of new way extensible config system and structure that we have, because it makes it much, much easier to slot something into every, point of the system, of the model. So actually, that's something I'm really looking forward to exploring, how we can integrate the models and the config with like a lot of the cool tools that already exist in the ecosystem. So I think that should definitely be possible and much easier now.
Okay, cool. Another question was concerning named entity recognition. Is it possible to use pre-trained transform models for tasks just as a named entity recognition?
I mean, the models, the examples I showed there, I think I even showed like a config for a named entity recognition component that uses pre-trained transformer weights. So yes, that's possible. We've pre-trained a few pipelines that you can download and test on some corpora, including named entity recognition corpora that are available. So yes, pretty much any model definition that you can write that predicts something that's useful in that context, you can also use transformer embeddings for.
Yeah,
Very cool. Oh, I have a quick question, Inez. So this is me being selfish again and like wanting to ask all my own questions. So one of the things that really came to mind from watching your talk was there's quite actually a lot of developer considerations. So almost thinking more about the end-to-end. And we spoke about this with Josh, one of our previous guests, where he was kind of saying, unfortunately, like the exciting experiment, like using different models and doing A/B testing tends to be like the smallest part of the project. And it feels like you've thought a lot about kind of how do we reuse different assets and stuff like that. So is that an ethos that Spacey is going to have moving forwards? Is everything kind of, we'll give you some out of the box, but actually you can customize so much?
Yeah, exactly. I mean, I feel like this has always been something that we wanted, and it's been like a process. And I think it also kind of reflects the ecosystem and the developments in the ecosystem and in the broader developer community a lot. Because when we started with Spacey in 2015, people really just wanted to have some named entity recognizer that was kind of, what you used at the time and just wanted to run it, maybe train it, that's it. Now, especially with the transformer embeddings, there's some people who still just want to have great defaults, something that just works. And of course, we want to be able to provide that. I think that's super important. But especially with the transformers, they're more like, you can think of them more of like a sub-network of like your larger network. And so that also means that you do want to work at a much more fine-grained level. You want to be working at the tensor level and do, use different prediction heads, whatever you want to do. And those are both workflows that are totally valid and that we want to support. And I think that was definitely something that really influenced that design that we went for Spacey 3.
Cool. Well, I think it's time also to get our third guest back into the video. Let's invite Verit again to the screen. Hi, Verit. Thanks for joining us again. You probably saw the session of Ines just now. What do you think about Spacey v3.0?
I think Spacey, I really like using it. I think that among the different packages, Python packages that I'm using for my research, Spacey is, I think, the most reliable and consistent package where you can just keep using the same code. It doesn't change. And they keep adding.
Oh, thanks. No, that's super nice to hear, because that's definitely something that's also important to us. Yeah. And that's something we're going for. So it's great, that it actually works like that.
Yeah, I think it's true that so when packages are being developed by people who maybe emphasize the research more than they emphasize the ease of use, then normally you would get packages that are in some way hard to work with, because you have to always, like if you want to use your code from 2 years ago, it wouldn't work anymore. But this is really not a problem with Spacey. It seems like it's very well thought in that aspect.
Thanks. But yeah, I think also the production use aspect is definitely what makes a difference. And also, I would never shit on research code, because there's research code has a place, and I also feel like it's not a researcher's responsibility to make sure that I don't know, their code runs on in production context and is fast and runs on whatever machine, or even runs on CPU. That's I remember seeing some Twitter thread where I think Matt said something like, well, look, asking whether it runs on CPU is a question does it run on a toaster? I don't know, does not matter. That's not what we're trying to do here. So I always think it's important to keep that distinction, and it's not the researcher's fault.
Yeah, and actually, I find it quite interesting. I love, Verit, that you use Spacey. Also, our previous guest, Elron, his chatbot software also used Spacey. So yeah, everyone's using Spacey, which is a treat. But one of the things I kind of wanted to say was it's nice to hear, Verit, that you're using it. And Ines, do you work a lot with research? Do you chat with people like Verit and kind of to hear what's going on in the space and kind of work that into your strategy?
Yeah, of course. It's always the idea has always been, well, we see what people are working on, what is working, and what also can generalize to a broader context, and what we can actually make useful for people. So I think at this point, with for example, the transformer model, we came up with an idea and with an architecture that actually makes it work. For example, for the multitask learning, you can share a component with other one transformer with other components. All of these ideas actually make it work well and make it useful. But there's always a point where you have a lot of very cutting edge stuff that we of course follow, but you always want to take some time and some distance to see what works, what makes sense, and what do we actually want to tell people to use. But the idea has always been, we see what works in research and how can we actually bring that to developers with a good developer experience.
We Vered talked a lot about bias also within data. How is that within Spacey? How do you handle that?
I mean, I think it's difficult to phrase it like that in terms of bias, is it good or bad? Like in general, well, sure, you have data and you train a model on it, and that model will reflect whatever is in the data, and that could be good or bad depending on what you want to do. Like, for example, if you want to analyze comments on Reddit that people have posted, you can train a model on that, and the model will be able to reflect the sort of language people use and what topics people talk about, and that's very interesting. But then if you take that model and you deploy it into production or use it in your chatbot to talk to people, that could be potentially pretty terrible, because your model might go and use very terrible language that it picked up from Reddit if you make it generate language or whatever. So I think or if you analyze text about people back in the day in science, that will have an incredible gender bias, because most of the people that are talked about are men. Not that women didn't exist, but women weren't written about. So that's a fact, and that's not something we need to fix. The problem comes when you're taking a model and you're using it, and what you're actually trying to do with it. And I think I think it comes down a lot more to that sort of awareness, rather than can a library fix bias? No, it's like bias is not inherently bad. It's just something that can have a really bad impact.
It's what you put, what goes in goes out.
Yeah, and I'm quite critical of this whole anti-bias as a service thing that comes up now, that it's like, oh, it's trendy to talk about, and now you have companies who are like, oh, we promise you a model that's like bias free, and it's like, and people are like, oh, great, if I could just pay you a few million and you give me a certificate that there's no bias in my model, great. So I think
Oh, have we? Sammy, are you there? We might have lost Sammy a little bit.
I'm here. I'm sorry. No, I'm here. No.
No worries. I thought it had frozen. Actually, I have a quick question following on from that, and this one's probably for Vered a little bit more. How you spoke a little bit about these the problems we see specifically with NLP when it comes to ethics, and so one of the interesting pieces I was thinking about was, I was like, how do you, when you're doing your research, kind of either comment or make reference to whether there would be bias? Because as you said, we know that a lot of maybe the data sets that are put together that research users tend to have some biases in them. How do you kind of work around that or work with it?
So I agree with Ines that it's mostly about the awareness right now. It is at various different levels. So first of all, maybe first deciding what kind of models to train versus what models are not a good idea to train. Like maybe I wouldn't train a automatic comment generation on Reddit data, because I know it's full of hate speech. But of course, I mean, we don't have control on every model we train would have various types of biases that are found in the training data. So we should mostly at this point be aware of that. And there are researchers focusing on these debiasing algorithms, but they're obviously far from perfect among several issues, because it's pretty hard to find these boundaries between what is a valid statistical fact versus what is something that is harmful or might amplify biases from things that were maybe true in the past, but we're trying to make them better in the future, like gender imbalance in various fields. And even when we maybe some people can take the decision on what should be valid and what not, then you still have to specifically define, okay, now we're trying to target gender bias, which we can expect to find in, I don't know, maybe texts related to occupations or I don't know. You have to specifically define, and there's no method that finds all the biases and fixes them. And I don't think there will be, because it's something that we as humans decide on.
Yeah, I was going to say, no, it's good to point it out as well that it's such a early area as well, isn't it? There are like lots of people working in that space, and hopefully we can find things but that can support maybe data scientists to know a little bit more about before they send things to production, whether, you know, certain flags that might be able to help them and stuff like that. So thank you for explaining that so eloquently.
Probably actually just one thing to add. I think also in general, the developer culture around it has an impact as well. It's it's not just the tooling. If you have if your team working on things isn't very diverse at all, then well, you might run into problems that are caused by that, because nobody thinks of these issues. And I think as you have more diverse teams with different backgrounds working on these things, we also have a higher chance of actually detecting more problems and making maybe even more reasonable decisions in the first place.
Yeah.
Ines, if you would compare Spacey compared with NLP tools that are API services from the big cloud providers, how would you compare it with each other?
I mean, I find it's kind of hard to compare because it's two very fundamentally, different things. The big appeal of Spacey or any library is that, well, you can build stuff with it, you can run it yourself, and you own your data and models. That's also what's incredibly important to, I would say, most of our users. People develop their NLP technologies in-house. You don't want to be sending all your data to insert large tech company here. You want to, own your data, train your own models, and that's what a library lets you do. That said, sure, there are also lots of API services that kind of run a custom Spacey model behind the scenes, even from larger tech companies. But I'm not saying, oh, it's bad, you shouldn't be using these. I think there's a lot of small functionality where, if NLP is not your main goal, could be pretty useful to just plug something in for some basic translation. Why not? But often, if you're really serious about what you're doing, the most interesting problems and the most interesting insights you're trying to gain by doing, for example, information extraction with NLP are the things that are incredibly specific to your problem and what you're thinking about. And that's the stuff that doesn't just generalize. And if you could download it from the internet, it wouldn't be very valuable for your company. So that's where people train their own models, and that's where a library comes in.
Yeah, true. I think it's a good comparison with what Josh was telling from VMware. They were using the BERT model, but of course they had to add a lot of own data to it to be able to recognize their own working vocabulary, because it's not some basic language that they're using. And the example he was giving about a switch, switch could be for switching on a light. It could be a network switch. It can mean so many different things. And again, that changes from one technology or industry to another industry. To go to something totally different, how do you feel about accessibility of specific models that have been built? For example, the GPT-3 that got released, they built it. They had previous versions where they said it was not so. It was a bit, well, they were not sure about releasing it. But is this things that should be released in open source, available for everyone, or you think it's better that big providers keep track of those things?
Big question. Big question, let's be honest.
Yeah.
So,
no, I have a pretty firm opinion about this. I think that they don't necessarily need, I don't think that we need to keep training huge models at all, but if we do, I do think that, I do support releasing everything and making everything publicly available. And I would give OpenAI the benefit of the doubt that they really didn't release their model because they were concerned about how it can be used for malicious purposes versus because they wanted to keep it to themselves. But it doesn't really matter, because eventually when one of these models are published, even if they're not released, it's relatively easy for some other research groups to to just train something similar, maybe not in the same scale, but it's not, I mean, they don't have like, they don't have some special architecture or something that wasn't known before. They just trained it bigger and on more data. So if there is a risk to that, it's already out there, and I don't think there's a reason for one company or another to keep their models private. Not for that reason, at least.
Okay, Ines, any
Yeah,
comments?
yeah.
on
I mean,
that?
I do think. Yeah, I mean, in general, yes, I agree with those points, and I also think, well, it's the the algorithms out there. That's not what you should protect. Although if you look in a completely different direction of data privacy more general, yes, I do think it's good for companies or whatever you're doing to be aware that, like, no, you shouldn't just be sending all your data to like some random startup or some random some large tech company and just give it to them. Like, it's important. I think it's good that more and more people are entering the field, are skilled in like the domain, and that companies are able to develop things in-house and own what they train and own their data, and don't make themselves dependent on like one or two large companies that then claim almost ownership over everything you're doing.
Yeah. Okay. Now, general AI, it's something that we hear a lot of. We have a lot of people who do not know anything about AI, and they think AI can fix everything, can fix the world. But we know that we're far from there. But do you think on NLP that we will ever going to be able to say these are NLP models that actually can understand everything?
No. I mean, it's a difficult question.
I was stopping myself not to be a skeptical academic, but I would also add that no.
Yeah.
Just no
I mean,
as
also,
well.
define, understand, define human level performance. Like even the things we're looking at now, where okay, you have one system that on a specific task achieves above human performance.
Mm-hmm.
That's objectively impressive, but it also what it means is, well, on average compared to humans that have been presented this task. And that have done it under certain conditions and so on. Not necessarily the machine is better than a human, because it's like not.
Okay.
I think it's the wrong question to ask. Like, I always feel like when people ask about like AGI, it's like, are the machines going to kill us? And it's like, oh, if we're at that point, you have other problems. Like, it's not worth it to, like, I don't know, engage on that sort of level, because I think it's to the point there's so many other like more pressing questions and answers and problems.
Well, yeah, Berid pointed out many problems still that won't be getting us to that point, right? So no, it's so good. I guess maybe something slightly closer to home then for you is the direction we're going down at the moment with NLP. Is there other approaches happening as well that are a little bit different, and can you tell us a bit about them?
So I think that maybe just to add first to the previous question, I think that AGI is also the wrong question, because currently we don't train any model that's good at everything. We train specific models that are good at specific tasks on specific data sets. We're lucky enough to have these pre-trained models that have at least a certain level of being able to represent text in natural language, but we are building very specific models. Specifically for NLP, I don't know to say that we're not going to have a model that understands language, but it doesn't seem like we're on the way there now. And I think the vast majority of work on NLP currently is just based on deep learning. I would even say that it's quite hard, I think, to get a paper accepted to a conference, an NLP conference, if you're not working on deep learning. And I don't think that the model that understands language would come from just training larger models with, I don't know, more layers or more data. It definitely helps for some things, but we're going to have some combination with a different approach, which I don't know.
Yeah, I think this is it's interesting you say that, because I feel like this also lines up quite well with what we're seeing more from like industry use cases. And it's like, yeah, it's cool that you have these language models, you can do a lot more that previously wasn't possible, but there's always an additional need for stuff that maybe, isn't an end-to-end prediction task or something, where you train a model to do exactly the business purpose, that exactly solves the business problem that you have. Like, that's also quite unrealistic. Like, many of our users, sure, they might want to use like the latest state-of-the-art cutting edge transformer system, but then they'd add you want to add a component on top that makes sure that it definitely always gets your company name correctly recognized, and you do that by writing a regular expression. Or you want to augment your system with stuff that you can look up somewhere on the internet and so on. Like, there's a real life solution often consists of a lot more parts.
Yeah, no, I think we see that a lot as well now. Like, I work a lot with cloud architectures, and so that is like a huge point that I sometimes like get across, where I'm like, often a lot of these solutions are like multiple pieces, and you pick the right stuff. Elron was talking a little bit about ensemble models, similar kind of idea, right? Using your strengths when you need them, and then kind of going down the right route, hopefully, to make something seem intelligent. And we also had a really amazing talk on kind of the history of AI in our first session at the start of October. And it's interesting, Vered, what you say, and Inez, are kind of about, okay, we're running down this neural network route, which was like the opposite in history. Like, we were running down like SVMs and like more kind of traditional machine learning routes, and then all of a sudden connectionism, and that became like the big thing, and it like broke the glass ceilings that we'd seen before. And so yeah, it's fascinating to think like, okay, like, we're working on this route now, and this is good, but I wonder what's coming next. Like, yeah, that always boggles my mind.
Yeah, also I think we kind of see people going a bit back to like, the language itself, and more, the computational linguistic side of things. So at least that's kind of, what I'm hoping. Because that stuff is relevant if you want to reason about which technology to choose. And I think that's what it comes down to. We have so many tools available, but you still need to pick the right tool out of your toolbox. Like, oh, you want to put a picture on the wall. What, have all these tools. Do you use a hammer? Do you use like, the heavy, I don't know, drill? What do you do? And that's a decision you still need to make. And often that does come down to, well, understanding the technology, but also understanding how does language work? How does language work across different languages? What are the challenges, and how do you actually solve the problem with all the tools we have available?
Somehow brings me a bit to the... okay, go ahead, Ferret, sorry.
No, I just want to say I think it's a good approach to think of deep learning as a tool out of many possible tools that we can use.
True. So it brings me a bit more to the question, if we look to the future, where will NLP bring us? What's new? What's going to change in NLP that we don't have now, but that we might have in, let's say, 5 years?
I don't know about applications, but I think maybe more collaboration with other fields, like maybe I mentioned in the end of my presentation, maybe combining language and vision. There's already some work on that, but I think maybe more of that, because we're starting to talk, like in the NLP community, we're starting to talk about the limitations of learning just from text, because humans don't learn about the world just from text, so you can't really expect a model to do that. We also see things and we hear things and use all our senses. So yeah, something like that, maybe a combination with vision or with robotics.
Yeah, I think from my perspective, one thing definitely we're already seeing, and that we're hopefully going to be seeing even more of, is more people from all kinds of different areas and domains and research fields using NLP in their work. Like, we already see a lot in like digital humanities, social sciences, but there's so many other fields. And with the technology actually becoming, more usable, and more people just, picking up from programming because, it works, and bringing in the domain expertise. So I think that's going to be really interesting. Otherwise, also, that's more kind of from a developer experience perspective. Like, there are a lot of, Python is probably one of the main languages people use, and there are a lot of exciting developments in that ecosystem, which I also, briefly mentioned in my talk, and which we're also, focusing on a lot in some of the stuff we're doing, like type hints, some of the new, new stuff you could do. And also all of that kind of also enables a much a closer a cycle between research and production, or it basically brings research and production closer together, or prototype and production. That's what I mean. Actually, research maybe should maybe also always be kind of separate. But like the idea of, okay, you're trying something out, you're prototyping something, you're actually shipping it. That sort of loop. If we close that gap, I think it will also be much easier to build systems that work.
Yeah. Oh, that's so true, isn't it? And I think now, I don't know about all of you, I feel like there's maybe like more of a demand than ever for someone in the data science space to have a really large set of skills. Like, you're not now just even focusing on the model elements, you're now focusing on like, how do I make sure this is production ready code? How does this route into config files and stuff like that? Interestingly, Inez, someone wrote us in the audience, said, Spacey V3 is super cool. I want to throw that one in there straight away for you. But they also just put, I'm just starting to understand a lot of the new elements. We just realized that the config system fits perfectly for non-machine learning projects. They said, did you consider having the config system as its own package instead of as a part of Think?
Yeah, that's a really interesting question. I mean, it's a good question because it's something we've been discussing internally. So I'm quite surprised that someone else had this idea, because we were like, oh, not sure if that's something people want. But like, yes, while we were building this, we were like, oh, even, I wasn't even thinking about like non-machine learning projects, but I was like, well, it should just be its own library, standalone. So yeah, it's something we've been thinking about.
Good stuff. Whoever that question was from, hit Inez up, you need a job. And then there was just one more from the audience as well, just to make sure our audience gets all of their questions answered by our amazing speakers. So how do the transformer models in Spacey v3 integrate with Prodigy?
That's also a good question. So Prodigy is our annotation tool, and it's a developer tool. You run it locally. It integrates very well with Spacey, obviously, because that's also a library we develop. And yes, of course, you'll be able to use these new transformer models in Prodigy, for example, to help you label your data, to suggest annotations for you that you can then, just to be more efficient. Instead of just doing everything from scratch, you correct the models' suggestions. But we still need a bit more experimentation here, because the reality is these models are a lot larger and a bit slower. So really having them in a loop is just a bit more more challenging. But yeah, like Prodigy will just use Spacey 3 out of the box soon, and then you'll just be able to use it like you currently use it.
Cool. Fabulous. Always good to hear.
I'm sure we have a lot of viewers who might be interested in NLP, but maybe never really started in it. How do you get started in a project, an NLP project? How do you start learning the skills for it?
Any resources you'd recommend that you think people do well with online? I'm always a big Coursera fan. Their machine learning course is unreal. So.
I was like, oh, maybe you're the better person to answer this, because you're much more classic NLP person.
Yeah, I was gonna say it's a bit hard for me to answer that, because I learned it in the university, so it's hard to recommend an online course that I know that is good. But I mean, there are many courses available. I would look maybe for maybe from one of the big universities. Sometimes they upload their introductory NLP course videos. I think maybe that could be good resource, but it's also depending on the need. If you just want to quickly learn how to develop a simple tool, then maybe just look for a tutorial for specifically what you need, as opposed to if you just want to learn about the field.
That's
I guess if you're interested in Spacey more specifically, we do have a free online course that I built, which is kind of interactive. You can do like code exercises, and it also sort of works, I think, as kind of a nice intro to NLP. and you learn Spacey along the way. And it's course.spacey.io. You can find it online, and you can just do it in your browser. So that might be cool. Like, it's not going to teach you all about NLP, but like I think it's serves that one purpose. And I guess from my experience, I always need like a project to work on. Like, I can't sit down and just learn a thing. I'm like, okay, I'm really bad at giving advice. I usually avoid giving people advice on these things. But if there's one piece of advice, it'd probably be like, well, I don't know, find something else you're passionate about. Like, maybe you're passionate about football, or you're passionate about food, and then you can somehow combine that with like some interesting problem or insight you want to get. Like, oh, maybe you want to analyze a bunch of text and find something out about it. And then you have this sort of extra motivation from a field or from an area that you know something about and that you're also interested in. And then, you built some app, built like a little website, write a blog post. It shows what you did. So I think for people who are like that and really need a hands-on thing, I think that could be a good way to get into it.
Great. Thank you very much. I think that's a nice closure for tonight, or for today, depending from where you're watching, of course. Ines and Verit, we thank you very much for your time, for the very interesting sessions you shared with us today. We're looking forward to see more about all the things you're doing around NLP. And thank you very much for joining us today.
Thank you.
Thanks so much. We'll see you soon.
Yeah. So with this, we're closing our third episode of the. Need to look into another. So we're closing our third episode of the Global AI October sessions. Don't forget, send something, #Global AI Community on Twitter. We will pick one of the tweets if you also add them into our form. So that's globalai.live/win-action. Just send us a link to your tweet. We will randomly pick someone, and they have the chance to win a $50 Amazon voucher. So who knows, maybe it's you. Amy, thank you very much for joining me today and hosting this. I think it was a very nice episode today.
Yeah.
I personally learned a lot. What about you?
Yeah, absolutely. All of our guests were spectacular, like they always are. It's gone so fast. I can't believe it's been 3 hours already. But yeah, just like huge thank you to all the attendees as well for submitting questions, because it really does, like, your questions are incredible. So yeah, do continue to spend time with us as Global AI Community and make sure you get your questions answered by these amazing speakers.
Yeah. So we had an introduction to NAI. We talked about computer vision. We talked today about natural language processing. And next week we're back, and we'll be talking more about advanced AI. So go to our website, register if you haven't registered yet, and we hope to see you all back next week. Thank you very much for joining.
See you later.